As someone who's a beginner to a cloud such as Google Cloud, which has over 200 services, you will always wonder what all services to learn and in which order. Isn't that? That is the reason I have published this video to teach you from the very basic, starting from how do we provision a free trial account in Google Cloud, what is a GCE instance, how do we provision it, networking, billing profile, payment, GCP Resource Hierarchy, GKE, BigQuery, and many other services which are essential for you to know as a beginner and till the intermediate level. So I have covered everything. It's gonna be a long video for the next 5 hours. Just sit back, relax, and grab a tea or coffee, whatever you would prefer. By the end of this video, I promise you your Google Cloud fundamentals will be top notch and you should be able to tackle any complex problems by your own after this. So let's start with the video. If you are new here, my name is Piyush and I publish content on cloud and DevOps, all three clouds, Azure, AWS, GCP, and on DevOps, Kubernetes, CI/CD, and everything that is related with it. So check out my channel, subscribe this for more such videos. And yeah, without any further ado, let's start with this video with the first topic of how do we provision a free trial account in Google Cloud. To register a free GCP account, you would head over to google.com and search for GCP free tier. Then hit over to the first link, and over here it will have an option to get started for free. Click on that. Once you do that, you'll be presented with a sign up wizard. So make sure you verify your account information, your name, your email address. If you want to use a different email address than your Chrome profile, then click over here, switch account, and use the other address that you want to use. So this free trial account comes with $300 of free credit that you could spend in next 90 days. There are some limitations of using this credit, and many of the services will still be chargeable. So make sure you watch the video till the end because I'll tell you some important details, some important insights about how to use it completely free and what are the limitations of it and what all the things that you need to keep in mind so that you won't get overcharged. So once the trial period ends, you won't be getting overcharged unless you manually upgrade to a paid account. This is written over here as well. Okay, so let's continue with the sign up. So you verify your country and select the one that is regional to you. Okay, for me it's Canada. Then select what best describes an organization or needs. So let's select personal project. Check mark this box. I have read and agree to the free trial terms of services and hit continue. Then it will ask you to enter your phone number for identity verification. Okay, and hit send code. It will send a code to your phone number. Once you receive that, you enter the code over here and hit verify. Then your contact information will be verified, and then it will auto populate your name and address from your Chrome profile if you have an active one, or you could just manually edit this by clicking on the pencil sign next to it. It will have your payment method and hit on start my free trial. So this payment method could be your credit card or your debit card or your PayPal account. So you can use either of those and then you can hit start my free trial. Once you do that, it will automatically create a billing account and a project for you as the default one. So this is just some feedback survey type questions. So you could just hit close for now. And these are some of the tutorials that would get you familiarized with GCP services. So I'll just skip these for now as well. Okay, so this is my GCP console over here, and at the top of the page you see my first project. So this is the project. If you have multiple projects, then it will appear over here. So let's say I have two projects because I have created one before as well. So there are two projects for me. The name is my first project for each of those because they were auto created, and that is why they have the same name. but a project is uniquely identified by its project ID, which is this one and which is unique for each of the project, right? So if you want to create a new project, you could click on new project over here, and then you could give it a name, okay, and provide the organization that you want it to be part of. I don't have any organization currently, so that is why it's not there. We'll have a look over these things like project organizations and everything in the later videos, but for this video I'm just gonna give you some basic understanding of GCP and how to get yourself started with it. So I'll hit on the home page over here. Let's discuss some more details. So over here, this is your dashboard. All the services that you would provision would appear over here, and you could see the real-time data like the API request is visible over here. And then you could set up some monitoring dashboards and widgets which will appear over here. From the left side, you would have all your services. So these are the pin services at the top of the page. Pin services are something that you frequently use. So you pin it and they would appear at the top of the page like these many. If you scroll a little down, you'll see more products. That means all the other services that are pinned and unpinned as well. So let's say you would be using compliance frequently. So I just pin it from here. Okay. And once you pin it, it'll appear at this section as well. You see compliance in the pin services. And the same way you could unpin any existing services that has already been pinned. So let's click on unpinning the marketplace. Once you do that, it'll be gone from here from the pin services. All right. So this is how you could use your services. So you select the service from here, from compute engine. Let's say you want to create a VM instance. So you click on that. So that's one way. Other way is to search it from here. You search for compute engine and click on compute engine. All right. So these are the ways you could search a particular service in GCP project. Now there are different ways of interacting with the cloud services. One is through console that we are already looking into. Other is RESTful APIs, which is programmatical access to the GCP services. And the third one is using the Cloud Shell or the G-Cloud commands. So you see a button over here which says activate Cloud Shell. If you click on that, a shell will be provisioned to you. A screen over here which you could just expand as per your comfort level. Okay, so Cloud Shell comes with the Cloud SDK, which is G Cloud, Cloud Code, and an online code editor as well with all the utilities pre-installed for you. So you then don't have to worry about any installations and everything. And it is also free for all the users. So you hit continue and it will provision a Cloud Shell for you. All right. So by default, it will create from your email ID @ Cloud Shell. And if you do a pwd in this, a home directory will be created for you as well. Okay. There are different options from it. Then you have terminal settings. In terminal settings, you could go to terminal preferences and change the color theme from dark to light or custom. Change the text size. Let's go for the large one. And the same way you could just change other settings as well, such as your font, your copy settings, your keyboard, and scroll bar as well. So these are all the settings that we have. Then it has a web preview option. Web preview, if there is a service that is already running on port 8080, let's say you have an Nginx server or Apache web server running on port 8080, you could just click on preview on port 8080 and it will show you the preview of that particular application. Or you could change the port as well if you want to use a custom port. Then this particular section will have some session information. And if you click on these three dots over here on the more, you will have option to restart the Cloud Shell and upload and download files. So to upload a file, it's pretty simple. You click on the upload, you choose the file, and then you hit upload from here. And the default directory is your home directory. You could change it from here as well. All right, and the same way you could download the file. So this is the Cloud Console plus this is Cloud Shell. And then we have another option which is Open Editor. So as I have mentioned before, it comes with an online code editor. So if I click on that, okay, it'll provision a code editor for you. So this is a code editor which looks pretty similar to Visual Studio Code or PyCharm or Atom or the other integrated development environments that you might be familiar with. So it'll have an explorer, a version control, and a few other things, right? So I'll just open a folder from here, file, open, and this is my home directory in the Cloud Shell. Hit over here, and this is the folder that is already there. So it has one file currently, readme and cloudshell.txt. If I click on that, it'll open the file in the right mode. Let's create a new file, new file, and then give it a name, test.txt. Let's add some content to it. Namaste Google Cloud, and I hit on Control S, or you could just save it from file menu as well, file save. Okay, basically the same thing. And then you could just switch to a terminal from here, open terminal. If I click on ls over here, now you would have two files, one which was already there, and this is what we have created. If we cat on this particular file, you would see the content that we have just entered. So instead of using VI editor or any nano editor, which is a command line, you would have a GUI based editor, and you could again go to that editor from here. Okay, so this is one way. The other way of using it, you open it in a new window from here, click on that. And once you do that, you don't have to switch between your Cloud Shell and editor. So it'll be presented to you in a split screen. So you see at the bottom of the page, this is the Cloud Shell, and over here is your core editor. Okay. So these were the other things. So let me just close the Cloud Shell. All right, this is what I was talking about, free tier usage limits. So even though you would have $300 of credit that you can spend in next 90 days once you start using the free tier account, but it'll have some limitations attached to it. First and foremost, not all the services of Google Cloud are covered in the free tier limit. So make sure you understand this very well before you start using any service. So these are the services that are covered over here. And let's say if you want to know what are the limitations attached to compute engine, then you scroll down to this section over here which says compute engine, and it will tell you like one non-preemptible E2 micro VM instance per month in one of the following US regions. So if you create any other VM than E2 micro in any other region except the ones that are mentioned over here, then you'll be charged as per the standard rates. Similarly, 30 GB of monthly SSD disk that you can use free of cost. Anything more than that would be charged as per the standard billing rates, and so on. So there are things that you can see over here as well, right? So the same applies to all the other resources that are covered under the free tier, right? Like GKE as well, and Google Maps, PubSub, and so on. If you scroll down a bit, it says any usage above free tier limit is automatically billed at the standard rate. You can monitor your control cost by setting up budgets and alerts. So this is really important. Then production ready images that are there with Google Marketplace comes with premium OS licenses that are not covered in free license as well. You still have to pay for the licensing cost of the services that you would use, right? Also, billing support is included with all the cloud billing accounts, but you should be a billing administrator to interact with the billing support. And other thing that you need to keep in mind is this technical support for free trial users will end on 15th June. So you won't be getting any support from GCP technical support team for the free trial accounts after 15 June. Then if you want to have the technical support from the Google, then you should upgrade your support plan. So make sure you read all the things over here that's been mentioned, and I'll paste this document link in the description section as well, so that you could keep it handy, follow it along, and you should be good to go. So now that we have logged into our Google Cloud Console, I'll go over here in this section where it says Compute Engine and look for VM instances. I'll click over there, and the first thing that will ask me is to enable the Compute Engine API. Remember, when you are using any GCP service for the first time, you have to enable the API associated with it. Like if you want to use GKE for the first time or Cloud IAM, you have to enable its respective API. So for this particular service, I have to click over here to enable the Compute Engine API. Without enabling the Compute Engine API, I wouldn't be able to use the Compute Engine service. So once the Compute Engine API is enabled, you will see the screen something like this, where you have an option to create the instance or import the VM or refresh, and all other options are visible, and you could go ahead and create your first instance. So to create an instance, click over here, create instance, and then give this a name. Let's call it test VM Linux. You could add labels as well over here. And based on the default configuration, the one that you see over here, you will see the monthly estimate pricing for this. So if you are using a GCP trial account or a free tier account, all the regions and all the VMs are not supported with that. So make sure you watch my previous video which I have posted earlier. I'll put the link in the description section below as well as in the title bar, and it will show you the different limitations that it has. For example, only few regions and few machine types are covered under the free tier. So I'll select the US West one, which is what I know is one of those regions. I could choose the zone as per my needs. So let's use this one, US West 1A. Over here, we have different machine families. It's been categorized in general purpose, compute optimized, memory optimized, or GPU. And the series is this one. So if you select compute optimized, you'll see the option as C2 and C2D. If you use memory optimized, then you'll see M2, M1, and M3, and so on. So there are different categories of these machine families. So I'll go ahead in the first one, which says general purpose, and I'll use the E2 family. And inside that, I'll use the machine type as micro. So only E2 micro is covered under GCP free tier account, and it will have one shared core of vCPU and 1 GB of memory, which should be sufficient for our demo. And over here you'll see the monthly estimate have gone down from $28 per month to $7 per month. But this charge also will be covered under the credit that you get from the GCP free tier account. So to verify the same that you are covered under this, you scroll down at the bottom of the page and you'll see your free trial credit will be used for this VM instance. Okay, so we are good till here. We have selected a region, zone, and then series and machine type. Now these are some of the options, whether you want to use it as a recording tool or a screen capture device. I don't need it at this moment. Then there is a concept of confidential VM service. We don't need that as well. You could deploy your container images on top of this VM. I'll skip this for now. Then in the boot disk section, you have the option to select the VM image that you want to use. By default, it is Debian GNU Linux 11. So I can change it by clicking over here, change button. I could choose my operating system from Linux based or Windows Server. Currently Mac is not supported. So I'll choose Ubuntu from here, and you could just leave the default version, or you could select from any of the available versions. Then there is this boot disk type, whether you want to use a balanced persistent disk, extreme SSD or standard persistent disk, and the size is 10 GB. Okay, so I'll use the default configuration. There is this option to use custom images as well, but we haven't created any images or snapshot yet. That is why it won't be visible for us. And here you'll see different snapshot if we would have created it already. So it's not there. Okay, so I'll just select the configuration that we have set for the public image. Then there'll be a service account created by default with the VM. So this would be the name of it, or you could just select no service account if you don't want to create the service account. I'll keep the default one. And then it has access scopes, which defines how your VM will interact with other GCP services. So I'll select the default access, but there is an option to select full access to all cloud APIs. That means Compute Engine API will be able to communicate with all the APIs that is available for us to consume, or you could select the particular API that you would want to use. Okay, so these are the different options available for that. Let's say if you want to use Cloud SQL, then it says none or enabled. If you want to use storage, and it says if you want to have read only access, write only access, read write, or full access. So you could define the level of access as well as the type of API that you would want to use. So I'll keep it default as well. Then in this firewall option, we could select if we want our application to be available over HTTP or HTTPS port. Like if you have installed a web application on your VM and it will be publicly available for the users to consume, then you could allow HTTP and HTTPS traffic. Right. Then we have this option which says networking disk security management and sole tenancy. You could expand it by clicking over here. We will be doing a deep dive into the networking section in a separate video. So let's continue from here. There is an option to add the additional data disks. Currently, the VM only has one boot disk attached to it, which we have selected. And you could use to select this one, which says add new disk. Okay, you would give it a name, description. You select if it's gonna be a blank disk, that means you have to format it and make it usable, or you would want to create it from a disk image or a snapshot, right? Then the disk type, so these are the same disk type that we have seen before. Okay, disk size, it could be anything between 10 GB to 65,536 GB. Optionally, you could create a snapshot schedule as well to make sure that your data in the persistent disk is getting backed up regularly. Then you select your encryption type, whether you want to use a Google managed encryption key, a customer managed encryption key, or a customer supplied encryption key. Then you could select the deletion rule. This is really important. So when deleting instance, there are two options: keep disk or delete the disk. By default with the data disk, keep disk is enabled. That means even if you delete your GCE instance, the additional data disk associated with it would not be deleted. It will still be there. So you'll still be getting charged for it and it will be there for you to use in the future until and unless you explicitly delete it. So you could change the behavior of it by clicking over here, delete disk. So this particular deletion rule is different for the boot disk and for the additional data disk. So for data disk, it is selected as keep disk. However, in the boot disk, it is selected as delete disk. All right. And once you fill all the details, you could click over here, save. I'm not gonna do that for now. So I'll just close this pop-up. The next one is security section. In this security section, you could select how you would want your user to connect to the VM. By default, when you connect to a VM using this console or using the gcloud SDK, your SSH keys are automatically generated. So this is the default authentication and authorization mechanism. But you could use other permissions as well, which says control VM access through IAM permission. You could create a IAM role, attach it to a user or a group of user, and that would be used for your authorization or authentication. And you can also enable the MFA over here, multi-factor authentication. Or you could go ahead over here and add manually generated SSH keys. You use a third party tool to generate the keys and then you upload the keys. Then we have management option where you could add your user data script, like a startup script which will be executed after your VM is started. So you add the commands like this: apt-get update or apt-get install nginx. So if you do that, these two commands will be executed once the VM is up. So this is what startup script will do. Then you could add your metadata over here. It is basically a key value pair where you add the item, you enter the key and the value. Then on this next section, which says availability policy, you could select your VM provisioning model. The options are standard or spot. Standard is the by default policy that is available. But if you go with the spot, you will see a drastic decrease in the monthly price estimate. It was earlier 7 dot something dollars and now it is just $2.83. This is because the spot instances or the preemptible instances comes with a lot of limitations. You could go over here in this link, which I'll provide in the description section, and you can read about all the instance limitations. So the first one is compute engine might stop preemptible instances at any time due to the system events. So these are not highly available or this would not be running all the time. So if your application is running batch workload that can be restarted at any time, only then it is suitable for you. Then compute engine always stops preemptible instances after they run for 24 hours. So 24 hours is the maximum, lifetime of a preemptible VM. Then they might not always be available and it is not covered under service level agreements and are excluded from compute engine SLAs. And the Google Cloud free tier credits for compute engine does not apply to preemptible instance. So make sure you read all those things and see if this preemptible VM is a suitable choice for you. Right. So I'll just choose standard again. Then it says on host maintenance. When your compute engine performs periodic infrastructure maintenance, it can migrate your VM instance to other hardware without downtime. So this says what you want to do in that case. So if you want to migrate to a VM instance, which is a recommended, or you would want to terminate the VM instance. So you can select this option. And then there is this automatic restart. Again, if you want to have your VM restarted in case there was some system crash or a hardware failure or a software failure, or if you want to keep it off, then you can use that as well. And if you scroll up, you can verify all the details that you have looked into. And if you could go back to this section, boot disk, and click on change and click over here, show advanced configuration, you will see the option of deletion rule here as well. This is the same one that we saw in the additional data disk section. The only difference is that the default option over here is delete boot disk. That means the boot disk, boot persistent disk will be deleted when you delete the VM. Okay, so make sure you know what this is all about. So once I verify everything and once everything looks good to me, I could click over here, create instance, cancel it, or generate the equivalent command line. So if I click over there, this is a gcloud create VM command that you could use if you want to provision your VM from the command line. So I'll just copy it from here and close it. And I just keep this command handy when we'll be provisioning the instance from gcloud SDK. For now, I'll click on create instance. and it will just take couple of minutes and the VM will be created for you. So I'll just pause the video for a brief moment and we'll come back to see. Alright, so our VM is now up and running. You'll see the status is green and is running. The name was this. It was provisioned in this zone that we selected. It has an internal IP and an external IP associated with it and a network interface card. You could log into this VM by any of the following methods: using a new browser window or on a custom port, or you could use a user provided SSH keys, or you could use a gcloud command to SSH into the instance, or use another SSH client like Putty or Mobaxterm. Right. So one way is you click over here and it will open a pop-up for you. It will transfer the SSH key to the VM. It will automatically generate those keys and then transfer it to the VM. And then it will establish the SSH connection with the VM. So once you do that, you'll be logged in. And let's say if you want to see the host name of this server, you could do a hostname -i, and the internal IP is 10.138.0.2. If you go back over here, this is the same one, 10.138.0.2. So this is how we logged into this particular server. If you want to use the gcloud command to do the SSH, click over here, you say view gcloud command, copy the command from here. It basically has the details gcloud compute, SSH, and then specify the zone in which the VM was provisioned, name of the VM, and the project in which the VM was created. I just copied it. You could run it in a Cloud Shell from here, or if you can just close the window and click over here, activate Cloud Shell. It will open a new Cloud Shell window for you at the bottom of the screen over here. And the command that I have copied before, I'll just paste it over here and hit enter. It'll ask you to authorize or reject the credential request. I'll click over to this, authorize. Do you want to continue to generate the SSH keys? I'll click yes and then hit enter once more. And then it will create a SSH metadata key for you. Okay, I'm in the server and you could verify again with hostname -i 10.138.0.2. This is our internal IP of the VM. All right, let's do an exit on this. And now we'll try to create a new VM with the gcloud SDK. So I'll just clear the screen and then the command that I've copied before, I'll just change the name over here because this VM was already created. So I'll give it a name test VM2 -Linux, and rest of the details I'll keep it same. I'll just delete the service account as well because this service account was also created already. And then I'll update the device name as well to test VM2 Linux. And when I've verified everything is as per what we wanted to provision, I'll just copy this command from here and I'll paste it over here in the Cloud Shell and hit enter. Okay, it will provide you these details like this VM was just provisioned in this particular zone. Type is E2 micro. This is non-preemptible. That is why this field is blank. Internal IP is 10.138.0.3 and this is the external IP. Let's see if it is present over here. Earlier there was just this one VM. If I hit refresh, you would see other VM as well, which is test VM2. This is what we have just created and this is the internal IP. If we want to do SSH, you just copy the gcloud command, click over here and go down. I'll clear screen one more time and I'll paste the command gcloud compute SSH with the test VM2 Linux as the VM instance. Hit enter and again it will add that keys Okay, I'm in the server. Let's clear the screen and verify the host name. Hostname -i. This is 10.138.0.3. So this is our VM2. We have verified it. Now to delete the VM, you just select the VM. Okay, and click over more action and delete. Are you sure you want to delete these two instances? If you click on delete, it will be deleted. And this will also delete two boot disk because the delete disk option on those VMs was enabled. So that is why those boot disk will also be deleted. Let's say someone accidentally clicked on this. Let's just unselect these two. Let's say someone accidentally did that and deleted the VM. Click over here and it will be deleted, right? But you would want to avoid someone accidentally deleting this particular VM. So what you will do, you go to this VM and you click over edit, and then you enable this option, enable deletion protection. When you do this, instant would not be deleted unless you uncheck this option and save the configuration again. So let's try this. Let's enable this and click on save. Okay, let's go back and let's try to delete the VM again. I'll select the VM, click over here, more actions, and now you won't see the option to delete. It is grayed out because the deletion protection is enabled on this particular VM. Now that we have seen how to provision and manage Linux-based VM, let's use the same method to provision a Windows-based VM and RDP into it. So I'll click again over here, create instance, give it a name, test VM Windows. I'll again use the same region. Okay. And I'll select the machine type as E2 micro. I'll go over here to the boot disk option and I change the operating system to Windows Server, and I'll select the option Windows Data Center, which would support a graphical user interface. So this one over here, which says server with desktop experience, I'll click over here. And by default, it will have the balanced persistent disk of size 50 GB. Earlier it was 10 GB. And if you see, the delete boot disk is also enabled because this is the boot disk. Had it been a data disk, then this option would have been keep boot disk, but we can always alter the behavior as per our needs. So I'll keep it default because I would want this disk to be deleted once the VM is deleted. Select this. I'll verify everything. I'll keep everything as default. I'll allow HTTP and HTTPS traffic. I'll click over here and these options will also be the same. Click create. Once this Windows VM is provisioned, we'll see how we log into that VM because it will be a little different than of Linux VM. We don't SSH to the Windows VM, we do a RDP. So let's see what are the steps of doing it once the VM is up and running. In the meantime, I'll just go ahead and delete this test VM, but I wouldn't be able to delete it directly because I have enabled the termination protection. So I'll just disable it first. So I'll go into the VM and edit, and I'll uncheck this box over here, click save. Go back to VM instances again and click over here and then delete. Now it will be deleted. Now it's showing me this particular error in the notification which says Windows VM instances are not included in the free trial. To use them, first enable billing on the account. You'll still be able to apply your free trial credit to eligible product and services. That means I wouldn't be able to use it with the Windows VM unless I enable the billing. So let's go to the billing dashboard. I'll open this in a new tab. I search for billing. So over here, I could either upgrade from here, or over here, I could just activate it, because Windows VM is not included in the free trial account. So I have to upgrade my account. I would still have that balance remaining with the credit, which is 385 Canadian dollars, that I could still use it with the services that are eligible to be used in free trial. So I click over here, upgrade, hit activate, and it says activated successfully. Continue. Now I'll go back to my compute engine, VM instances. I just go over here in the notification and click retry on the failed notification, and it will just resume the service from there. Okay, so the Windows VM is also being provisioned. It has an internal IP and an external IP. To do a login to this Windows VM, we have the option to RDP. If you click over here, it will ask you to connect using the RDP client. So you would have to first download the RDP file if you will be using a third-party client. So you click over here and a RDP client will be downloaded for you. You first have to set the Windows password. So this is the prerequisite. So click over here. You use a username or select the one that is already been given to you. Hit set, and then there'll be a password generated for you. So you copy it and hit close. Okay, so you have set the Windows password. You could set it from the gcloud command as well. So once you reset the Windows password, you download the RDP file and you edit the file. So I'll click over here, show in folder, and then I'll edit it. Okay, and make sure you add port 3389 after the colon at the end, so that it will try to connect on that port. You hit save and then connect. Then it will ask you to enter the password that was generated for you. So I'll just paste the password over here, hit OK. I'll say connect me to this. Alright, so here it is. You are successfully logged into your Windows VM that you created, and it comes with pre-installed Google Cloud SDK shell. Let's have a look at the resource hierarchy in GCP. Suppose you are working for an XYZ bank, which will be considered a GCP organization and is the root node of the hierarchy. It can be further subdivided into multiple sub-organizations or line of businesses such as foreign exchange, capital markets, banking, and so on. This categorization in GCP can be done using folders to provide an additional layer of isolation between sub-organizations. Then these folders can be further subdivided into different teams such as equity, derivatives, and so on. This categorization in GCP can be done using subfolders. There could be many folders and subfolders in the resource hierarchy, and these folders can be further subdivided into environments such as testing, staging, production, and so on. This is achieved using what we call projects. A project organizes all your GCP resources together. For example, you keep resources of your test environment inside project A and production environment in project B to separately manage those resources. You cannot create a GCP resource without a project. You can apply an IAM role at the organization level, which is basically a set of permissions. It can also be applied at folder level, subfolder level, project level, or in some cases at the resource level. However, it is applied in a top-down approach, which means the role applied at the parent node will be inherited by default by all the child nodes. You cannot delete the role or permission at the child level if it was inherited from the parent node, but you can always override it at the child level. Now let's head over to Cloud Console and see how we can create our first GCP project. Alright, so I have logged into my Cloud Console and this is the dashboard that we have already seen in the previous videos. So to create a new project, you could just click over here and it will show you different projects that are already present. So name of these two projects are same because project name is non-unique and it can be changed even after the project is created. It is just a human readable name of the project and it is not referenced by any of the GCP APIs. However, this ID, it was auto generated for you and this cannot be changed. To switch between different projects, you could just click over here and the project will be changed. Right? To create a new project, you click over here, new project. You give this project a human readable name, call it test project 101. And over here, you provide the parent resource of this project, such as a folder or an organization. Currently, I don't have any organization created for me and I just cannot create organization for myself. If I click on browse, it will just show you this, which says no organization. So there are some prerequisites for creating an organization. If you go to this URL over here, it will show you that you should be either a cloud workspace user or a cloud identity user in order to use the organization resource. And it will be automatically created for you once you sign up for either of those services, right? So I'm not doing either of those at the moment. That is why it is no organization for me. And one more thing, if you see over here, it will show you you have 23 projects remaining in your quota. That means there is a soft limit on the number of projects that you could create. I have already created 2 projects and it is showing me that you have 23 projects remaining in your quota. That means the soft limit is 25 by default, but you could always request an increase or delete projects by clicking over here to manage quotas, and it will open a case with GCP support and they will increase your limits if. All right, so for now I'll just verify the details and hit create over here, and in the notification bar it will show you that it is now creating the project, and once it is created it will show you as success. You could just select the project from here, right, and then it will be switched for you, or you could just do the traditional way, click over here and just select the project. That is how you would switch to a project. Now let us have a look at how you would shut down the project. So shut down the project if you want to delete all the resources within a project and basically stop incurring charges on those resources, then you would simply go ahead and delete or shut down the project. Right, so you go over here on the right side where it says setting and utilities on the 3 dots and go to project settings. Once you do that, it will ask you to verify these details, like this was the project name, project ID, which was generated for you. This is a unique number, and the project number was also auto generated for you. You could click over here, shut down, and it says to shut down project test project 101, type the project ID this. So I'll just copy the project ID from here. I paste it over here. There is a space at the beginning, so I'll just remove it. And it's also showing you that owner of the project will be notified and can stop the deletion within 30 days. So that means you will still have 30 days if you change your mind or if you want to reinstate the access. Project will be scheduled to be deleted after 30 days. However, resources may be deleted much earlier. So even if you delete the project now, it will still take 30 days to completely delete it. After 30 days, it cannot be recovered, but before that, it can be done. So I'll just click over here, shut down, and it is saying the same thing that we just saw. It will be scheduled to be deleted on 29th June 2022. Today it's 30th May. So we are good with that. Now let's go to Cloud Shell over here. Click over activate Cloud Shell. Right now, We could create multiple configuration to seamlessly move from one project to another or to switch the context between multiple projects. To view the current configurations, enter this command gcloud config configuration list and hit enter, and it'll show you the default configuration that we have. This was created when the project was created for you. So this is the name and this is by default active configuration. Rest of the values are blank, and these values can also be set by setting the environment variables. To create another set of configuration, you would run this command gcloud config configuration create and then name of configuration, which is project A. Hit enter and it will create a project A named configuration for you and activate that configuration for you. That means you are now in project A in the Cloud Shell. If you run the list command again, now you will see two configuration over here. First was the default one that we had. Another one was the project A, and right now project A is activated. There is no project in it. There is no default zone or region with it, right? But you could always set these variables. So this is how you move seamlessly between multiple projects and multiple configuration. You could either set your default zone, region, project, and account, but make sure like to activate the configuration after it's been created. By default, it will activate it for you. But if you want to move back again to the previous configuration, you would still use the activate command, which is this one over here, gcloud config configuration activate project A. All these commands on all those details, I'll put the link in the description section below. Don't worry about it. Alright, I have logged into my Google Cloud Console over here and I already have a Linux VM running. So I'll go to my compute engine from this side to VM instances. And this is the VM that I have running. It's called Test Instance Linux. It has an internal IP and external IP attached to it. To make any changes to VM or to do any operations to this particular VM, you just select the VM using the checkbox right here and then click over here to the three dots which denotes more action, and then you can do a lot of operations from here. You can just create a start and stop schedule to save the cost. If you click over here, it will ask you different options like name of the schedule, description, region, start time, stop time, time zone, initiate date. If you leave it empty, the schedule will take effect immediately, else it will initiate on that particular date and the time that you specify. Similarly, the end date and the frequency. If you are more comfortable with the cron syntax, then you can just enable this option from here, which says use cron's expression, and then click on submit once you are satisfied with all the changes. Okay, for now, I'm just clicking on cancel. Now let's go back over here again. And the other options that we see over here are delete, reset, stop, suspend, start, and resume. Resume and start is not enabled because the instance is currently running and you cannot start a already running instance. It has to be stopped first. And suspend operation is not supported by E2 micro. That is why it is also grayed out. If you delete the VM, you will lose all the data that is stored in a non-persistent disk attached to this particular VM. Or if it has the option of delete disk enable, then persistent data will also be deleted. So make sure you use this option very carefully and with proper planning. Let's go ahead and make some changes to the existing VM. So for that, you'll go over here where it says name. You click over the name and then click edit. There are some configuration that cannot be changed once the instance is provisioned. For example, the name of the VM, the zone in which it was provisioned, and so on. But there are some configuration that can be changed, such as the internal and external IP addresses attached to the VM. So to change that, you click over here where it says network interfaces default. You expand this by clicking over here. And if you scroll down a bit, you'll see two type of IP addresses attached to it. One is a primary internal IP. Another one is external IP. There'll be two type of addresses, internal or external. So the reason why we are using two types of IP has its own purpose. Let's say we have a cloud storage over here which would need access to this particular server. Let's call it CS. That cloud storage can access the server using its internal IP address. That means that internal IP would be internal to the GCP services. However, if there is any external application that would try to connect this server, let's call it EA, it will try to connect to this particular instance. It has to connect to its external IP because the internal IP is only internal to the GCP services and it cannot be accessed from outside. So if you click over here, now there'll be two type of primary internal IPs which says ephemeral and static. An ephemeral IP address is an IP address that doesn't persist beyond the life of the resource. For example, when you create an instance without specifying the IP address, Google Cloud automatically assigns that resource an ephemeral IP address. So in general, the ephemeral IP address is released if you stop or delete the resource. So once this server is stopped or terminated, ephemeral IP address will be changed. But if you use static IP address over here, it is persistent even if you stop or delete the instance. So it will be assigned to your project until you explicitly release it. So that's the main difference between ephemeral and static IP address. So let's keep it ephemeral for the primary internal IP, and we want a static IP attached to the instance as an external IP. So I'll click over here and create a new IP address. This IP address would be static. Let's give it a name, static VM IP. I'll hit reserve and this particular IP has been created for you. And then you click save. Now if you scroll down, you will see a static IP attached to it and the IP address is 34.83.66.53. Just keep a note of it. And if we go back, so I'll select the instance and then try to stop it. Let's stop the instance for now. Hit stop. Alright, instance is stopped now. So if we scroll over here, you'll see that that particular static IP is still attached to the instance. In general case, when you stop the instance, that IP would be released to the pool. But this is not the case. Even if you terminate the instance, that IP will still be there for you to use. Now let's go ahead and delete this particular instance. So I have selected the instance already and I click over here, hit delete and delete. Okay, it says instance is deleted and it's removed from here as well. Now if you want to see if you still have that external IP address attached to your project, let's open this in a new tab and you click over here, three dots, and then look for VPC network and then IP addresses. And over here you see there is one external IP address which is named as static VM IP, and this is the same IP address that we assigned. And it says in use by none. That means this IP hasn't been attached to any VM. And in the same way, you can reserve more external static IP addresses by clicking over here, reserve external static IP address at the top of the screen. To release this particular address, you select the resource and click over here, release static address, and this address will be released to the pool. But before doing that, let me try to create a new VM and show you how you can attach this particular IP to a new VM as well. So I'll hit cancel for now. I'll go back to my VM instances and I quickly create one VM. Click over here, create instance. Let's call it test VM. I'll put that in the same zone, US West 1, and then machine type as E2 micro so that it is supported by GCP free trial usage. Then I'll go down a bit, networking, and then select this particular option over here. Scroll down, external IPv4 address. By default, it is ephemeral for both internal and external IP. If I click over here, now this particular IP is visible in our drop down. So I'll select this and hit create. Alright, so the VM is provisioned, and if we scroll a little to the right, you'll see the same external IP is attached to that particular VM as well. So now I go back to IP addresses. I have selected the IP address and hit release static address to delete the static IP. Hit delete. Okay, so the address is deleted. Let's go ahead and see how you can create a machine image to back up all the data stored as part of that particular VM, including metadata, permissions, configuration, and data from the multiple disks of that particular VM. So you go inside the VM and then click over here, create machine image, or you can do that from this tab as well, which says machine images. So you could choose either of those. I'll click over here, give this a name, call it VM image 1, select the source VM instance for which the backup needs to be taken. So there is only one VM running. So I'll choose that. Set the location, whether you want the backup to be multi-regional for high availability and disaster recovery, or you just want it. For this particular demo, I'll just select this as regional and select the location from the drop down, or just leave the default one. Select the encryption type and have a look at the advanced configuration, which will have all the details of your VM image. There are some things that would not be covered as part of the VM backup, and those are local SSD data, in-memory data, name and IP address of a VM, right? So please make sure you remember this point. Once you review everything, you hit create and the machine image will be created for you, and you can easily go ahead and create a new VM from that machine image. So the machine image is now ready. I'll just open the image and hit over here to create the instance from that image. Once you do that, it will still ask you to enter the name of the VM, because as we have discussed before, name cannot be used as it was there in the source VM. So you can choose a different name than the test VM. So we'll call it VM test 2. Verify other details as well. So you see the default region was selected as whatever it was there in the source VM, and all the other configuration like E2 micro instance that we have selected. And if you verify everything is correct, you can just go ahead and hit create the VM. So this is one way to take the backup, but this particular method will cost you a lot of money because VM images are huge in size, and you will be charged the per GB storage cost of the machine image for that particular region. So when you don't want to overspend on VM backups but still wants to backup critical data for various purpose, then you can use disk snapshot, which is just the backup of that particular persistent storage attached to the VM. So let's go back to that VM. It doesn't have any additional disk attached to it, but it has a boot disk attached to it. So we can create the backup of this particular disk using the snapshot. So from the left side, if you scroll down a bit, you'll see disk and snapshot. So you go to disks. So you could either create a new disk from this particular disk or click over here, actions, and you can create a snapshot. Give this snapshot a name. Let's call it snapshot test. Select the source disk for which the snapshot needs to be taken. Select the location as regional or multi-regional. Verify everything and hit create. Hit over here, hit refresh. And now you see the snapshot was successfully created. You go inside the snapshot. You create the disk from this particular snapshot and attach that disk to a VM instance. And then your VM will be cloned as per your needs. Right? If you go back, you'll see another option which says create snapshot schedule to make sure you are regularly backing up your application and your VM instances for disaster recovery and maintenance purpose. You could also create a snapshot schedule. From here, it will have all the other options like snapshot storage location, schedule frequency, start time. You can also set a lifecycle rule to auto delete the snapshot after a certain number of days. By default, it is 14, but you could put any value over here. So if you put 30, it says after you delete the disk that use this schedule, delete snapshots older than 30 days, and it will delete the snapshot after 30 days, right? And basically that's it. And if you hit create, this schedule will be created for you. So I've logged into my Google Cloud Console, and I'll go over here in the search bar and search for marketplace. Hit over here. Once you are inside the marketplace, you will see a lot of packages that is there for you to use. These are again the production grade packages. And once you choose to deploy one of those, you wouldn't have to worry about configuring the virtual machine, storages, or network settings. You can optionally alter those settings, but you can also go with the default one. So let's say I would like to install a lamp stack. So I'll just search lamp from here and hit enter. And now over here as well, you'll see there are 50 results just for the lamp stack. So the first one over here is lamp stack click to deploy virtual machine. It consists of Linux, Apache, HTTP, MySQL, and PHP. Once you click over here to the package and scroll down a bit, you will see the software versions inside that particular package. For example, it has Apache 2.4.38, and it has PHP 7.4.29, and so on. And for the pricing, you scroll down a bit and you will see there is no usage fee for this particular package, but it will have the infrastructure cost for one shared vCPU and 2 GB of memory, which is 1557, and there is a storage charge as well for 10 GB of SSD disk, which is 60 cents. And then estimated monthly total would be your 1617. And when it comes to providing support based on the SLAs, it says Google does not offer support for this solution. However, community support is available on Stack Overflow. Please keep that in mind that solutions deployed by Marketplace are third-party softwares and are not supported by GCP support. Google also provide Marketplace solutions. Make sure you check the details of the Marketplace product before start using it. For example, if you are using a Bitnami image, you should be contacting Bitnami support team and not the GCP support team. To deploy a particular solution, you select the image. Let's say we select this one and hit over here to the launch after verifying all the details like the package content, VM instance size and type, the estimated monthly cost, and the support provider, right? Once you've verified everything, hit over here, launch. And if you are using it for the first time, it will again ask you to enable the APIs. So because we already have Compute Engine API enabled, it will ask you to enable rest of the APIs such as Deployment Manager and Runtime Configuration API. So I'll hit enable. Okay, once it is enabled, it will redirect you to the setup screen where you could just name your deployment. This is not your instance name, but your deployment name. Let's call it test deployment. Select the zone in which you want it to be provisioned. So I'll just keep it default for now. Then you select the machine type. So by default, this is E2 small. Let's select E2 micro, which is even a smaller one. And you will see the change in pricing structure over here on the right side. Then optionally, you could install PHP MyAdmin, or you could just uncheck this box if you don't want that. It has a boot disk of type standard persistent disk, and this is of 10 GB. You can update the size from here as well. And this is the default network interface attached to it with /20 as the subnet mask. And you could optionally allow HTTP or HTTPS traffic from the internet. That means from source IP 0.0.0.0, or you could just specify the source IP range over here if you don't want it to be publicly available over the internet. These are the options for Stackdriver logging and monitoring. Stackdriver, which is also known as cloud monitoring and cloud logging. You could enable those and you could just accept the GCP marketplace terms and hit deploy. Once you deploy, you will see the screen something like this. So this is using some Jinja template to provision the infrastructure for you. And over here, you'll see there is one VM instance created. There is a password generated. And there are two firewall rules created, one which allows traffic on port 80, another one on port 443. So you see how easy it is to provision an infrastructure stack without having to configure all the minute details. It says it has some warnings. Hit over here, view details. It says some of the features is in beta, so it's fine for now, right? I'll just go back and it is created. Now you'll see you'll have GCE VM instance created. So you can go to the VM instance from here or from the GCE console itself. So I'll just click over here and hit over here manage resource or directly SSH into that. Let's click on manage resource and you'll see all the details over here, right? This is the VM name. We gave the deployment name as test deployment. That is why this VM name is test-deployment-VM, which is auto generated and it was created in this particular region. Status is running. Okay, so I'll just click over here and hit SSH. Let's do SSH into the VM. Hit connect. All right, I'm inside the VM. Let's do php-v and it says PHP 7.4.29 has already been installed. Okay, I'll just clear the screen and you'll see other details as well. This is the site address. This is the admin URL for PHP my admin. If you click over here, it will open a new tab for you. Right, so this is PHP my admin page and here are the details of MySQL user and the password, which is a temporary password. So if you go back over here again, even though you could just run a apt-get update or a apt-get install a upgraded version, let's say upgrade install PHP 8. Even though you can do that, you can run this command, but this is not supported as per the support agreement. So if you do that, your support will be violated. You won't be able to get support from the required third party seller or the first party seller, which is GCP. So in order to avoid that, let's say you have to upgrade PHP version from 7.4.29 to 8.0, then go to the marketplace and look for a newer image of version 8 instead of just upgrading it from here by yourself. So you have to redeploy the package with the required configuration. And if your supported package is not available in the marketplace, then you could just create your own instance in GCE and configure them to run your own apps and services. Make sure you know all the limitations of it and use it if that is a good fit for your use case. So mostly it is intended to be used as a isolated production ready system, and if you need to upgrade the version of a software package, you would have to redeploy the package using a different cloud marketplace image. So let's say you don't want to use the services anymore due to any particular reason, you just hit over here delete and then it will ask you two options whether you want to just delete the deployment but keep resources created by it, or delete the deployment as well as all the resources created by it. So I'll just select the first version and hit delete all, and all of your resources will be deleted after this. Okay, it's been deleted and you don't have any deployment present right now. So what exactly are the managed instance groups? An instance group is a collection of virtual machine instances that you can manage as a single entity. For example, MIG1 is a managed instance group having 5 instances. To create a managed instance group, you would first have to create an instance template, which would define the VM configuration like name, machine details, OS image, security, disk, firewall, networking, and so on. Instant templates are designed to create instances with identical configuration which scale based on the demand. This is also known as auto scaling. Let's say you set the auto scaling on CPU utilization at 60% threshold. So when CPU utilization for any of the VM goes above 60%, a new VM will be added to the managed instance group based on the instance templates configuration. When the CPU utilization goes below 60%, the newly added VM will be deleted from the instance group. Along with the auto scaling, it has some additional benefits as well, such as high availability. If a VM in the group crashes or deleted or stopped accidentally, then managed instance group automatically recreates the VM using the instance template. The next one is fault tolerance. You can choose from regional or multi-zone deployment that protects the application against zone failure. Your application will still be serving traffic from the remaining available zone with the help of load balancers. You can set health checks on the VM on a specific port that recreates the VM if a certain number of consecutive health check fails. Now that we have seen what exactly is a managed group instance and what are the benefits of using it, let's go ahead to our Cloud Console and provision one managed instance group. So I'm logged into my Google Cloud Console and I'll search over here instance groups. The first result over here, I'll click, and then as it says on the screen, create instance group, I'll hit over this icon. Then I'll enter some basic details. Let's give it a name, test instance group, and then create an instance template. If you already have created an instance template, it will be appear over here as a drop down list, but we don't have anything. That is why it is asking us to create a new instance template. So I'll click over here and again I'll give it a name, test instance template. You could optionally add labels. So consider this as the image which has all the configuration required to provision an instance, so that when one of the instance in your managed instance group goes down, the another one will be provisioned as an identical copy of the previous one. And this template will make sure that all the instances within a managed instance group will have the identical configuration. I'll just select the series as E2 and give the machine type as E2 micro. I'll keep all the options as default and allow HTTP and HTTPS traffic. And I'll hit save and continue. So my instance template is created. Now I have the option to provision this in single zone or multiple zone for high availability and redundancy. So for this demo purpose, I'm going to create this in a single zone. If you select multiple zones from here, it will give you an option to provision the instance in multiple zones. So let's say you have 3 zones and the target distribution shape is even, then it will provision 3 instances in 3 different zones for high availability and redundancy, right? But for this demo purpose, let's select single zone and our instances will be provisioned in US Central 1A. Then there is an auto scaling mode to automatically add or remove the instances to the group based on the matrix threshold that we specify. So let's say we select this option, add or remove instances to the group, minimum number of instances as 1, and let's put maximum number of instances as 3. So whenever there is a CPU utilization greater than 600, it will scale out and add one more instance if the number of instances are less than 3. Then we have cooldown period. Cooldown period is the time it would take for you to initialize from boot time until it is ready to serve the traffic. Sometimes a virtual machine takes time to boot up and install all the prerequisite softwares and packages. So during that time, if the autoscale detects that your instance is not up, it will try to spin up one more instance. So this is not what we want. So let's say our VM takes 1 minute of time to provision. So we'll put cooldown period as 1 so that only after this particular period it will try to add one more instance if it is not available. Then we have scaling controls. Scaling controls will set some limit for scaling the group. Then we have auto healing. It provides the ability for VM to auto heal. So we could just set health checks based on a protocol. Let's go ahead and create a health check. Let's call it test health check on HTTP port. So it will try to reach out the server on port 80 based on this criteria that we have set. So it will check after every 5 seconds and it will time out in 5 seconds if it doesn't get the reply. Healthy threshold is 2. That means 2 consecutive success will result in a healthy threshold and 2 consecutive failure will result in an unhealthy threshold. Whenever it will find that there are 2 unhealthy consecutive failures, then it will report the health check status as failed and it will just restart the VM to auto heal from the failure or the crash that it might have. Right, so I'll click over here, save. Okay, initial delay is 300 seconds. This is similar to cooldown period. It just cooldown period is for provisioning new instances as part of the auto scaling group, but this initial delay will wait for 300 seconds to perform first health check. Right, so you could just update this number based on your use case. Okay, and there'll be some advanced configuration over here. So this configuration is only available when we are not using auto scaling, but because we are using, this is disabled. These were all the details that we have to enter. So there are 3 type of instance groups. We have selected the first one, which is the managed instance group for stateless applications. This is ideal in case when you are serving the stateless and batch processing data. Then there are 2 other. The second one is stateful managed instance group that have persistent data or configuration such as database or legacy application. And then we have unmanaged instance group. Unmanaged instance group, you have to manually manage those VM and load balance them. All right, so these were the 3 types and we have already entered all the details. So let's go over here and hit create. So I'll pause the video for a few minutes over here and then I'll come back because it will take some time to provision all 3 VMs. Okay, so it says instances is 1. That means it has provisioned 1 instances so far because that was the minimum number of instances that it should have. Let's open this in a new tab and see what it has done so far. So the instance was created. So if I click over that instance, you will see the same configuration that we set as part of the instance template. You see E2 micro and US Central 1A. That's what we have selected and rest of the options were default except HTTP and HTTPS traffic, which we enabled explicitly. If you hit refresh, it says auto scaling is on with target CPU utilization as 60%. Now click over here. If you want to see the details that we have configured for this particular managed instance group, you click over here, details. And over here you will see the auto scaling, minimum number of instances 1, maximum is 3. So currently it has 1 instance and it will add more instance when the CPU utilization will reach 60%. It will wait for 60 seconds before checking the CPU utilization. Auto healing health check was set 300 seconds as initial delay. So this is the time it will wait as well. And then you can check monitoring and errors from here. So it says current minimum, current maximum, and then we don't have much CPU utilization right now. That is why there isn't much data over here. And basically all the details you could see from here. Then if there is some auto scaling errors, it will report over here. So if you want to, once the servers are provisioned as part of managed instance group, you could go ahead and edit the managed instance group configuration. Like you could change the minimum number of instances from 1 to 2, so that it'll always have at least 2 instances running for high availability. And you could spread that across multiple zones. Instead of CPU utilization as a threshold, you could specify based on a schedule as well. Let's add the minimum number of instances as 2. Lower the initial delay to 50 seconds. Okay, and hit save. Now you'll see over here it says minimum as 2 and maximum as 3, and it will try to add one more instance. So I'll go back and hit refresh over here. Now it says instances are 2 as part of this particular MIG. So now you'll see 2 instances. One is this one, another one is this one. This is still getting created. So now you see, even though the instances are 2, still the health check status is showing as unhealthy. It is because we have not created the firewall rule, which allows the health check to be performed. So we'll be seeing firewall rules later in the playlist, probably in the networking section of this course. So for now, just try to understand the concept behind it. So now our test IG, which is a managed instance group, has 2 instances that was provisioned from an instance template. So the process is like this. You create the instance template, which has all the details like CPU, machine type, machine image, and all those things. And from that instance template, you create managed instance group, which will have certain number of VMs running. So it will provision those number of VM for you. Let's say you have selected it as 3. So it will create 3 VMs for you, and auto scaling will keep checking the CPU utilization on these servers. And whenever it finds out the threshold is greater than whatever you have set, let's say you did set it greater than 60%, then it will try to add more VM to it if the maximum number is set as 4, right? And whenever the CPU utilization goes less than 60, then it will delete the VM from the managed instance group, right? So this is how managed instance group work, and this is how you would attain high availability, auto scaling, and auto healing capabilities. So let's now go to instance templates over here, and this is the instance template that we have created. So once you have created the instance template, there is no option to edit. You see, we cannot edit the instance template once it is created. We could edit the managed instance group to use a new instance template, and we can just replace this one with the newer one, but we cannot edit it. Now you could also create new VM directly from this particular instance template. If you don't want that VM to be part of an instance group, you could just click over here, provide basic details like name, description, and it will auto populate the rest of the details from the instance template, like E2 micro is the machine type that we selected, and it will have HTTP and HTTPS enabled by default. Second option, you could create a similar instance template from this one. So it will be like updating a newer version of this particular instance template. You could do that as well, right? So this is a new instance template with name as test IT1. The earlier one was test IT, and you could just make your changes from here. Let's say instead of E2 micro, I would want to use E2 small. So I'll just click over here and hit on create. So this will create a new instance template for me. So I'll wait for it to be provisioned. Now I go back to my instance group, which is over here, and hit over this particular group, click at it, and I can just update the instant template from test it to test it 1 and then save it. Okay, so you see it has both the templates attached to it. That means the existing VMs will not be replaced automatically with the new template, but when there are new VMs added to this MIG, then only the new template will be used. So if you don't want that and you want instantly replace your VMs, so let's go ahead over here and delete the instances. Enter delete, says instances from group deleted. Now let's go back, and it has provisioned 2 new instances, you see. Okay, so these 2 instances were deleted and these 2 instances just got provisioned, and the new instances using test it 1 as the template. So the earlier template was removed. So let's go back to VM instances over here, and you will see one instance is already running and the other one is still in progress. It's being provisioned and soon will be running. And now if you see this VM, let's go ahead inside the VM. And over here, the instance template is the newer one. That means the machine type is E2 small. This is the change that we did as part of the template update. We didn't actually updated the template, but we created a new template and replaced the template in the managed instance group. So what exactly is a billing account? A billing account is a GCP cloud level resource which tracks all of the costs such as your charges and usage credits incurred by your Google Cloud usage. A cloud billing account can be linked to one or more projects. You can link billing account from other organizations as well. Project usage is charged to the linked cloud billing account and it results in single invoice per cloud billing account. You cannot use multiple currencies for different projects that is linked to a single billing account, and billing account also defines who pays for the given set of resources. Payment profile are connected to cloud billing account and it stores your various payment instruments such as credit cards, debit cards, bank accounts and other payment methods that you have used to buy through Google in the past. Payment profiles are managed outside of your cloud organization in Google Payment Center. This is basically a central location where you can manage the ways you pay for all your Google products and services, such as Google Ads, Google Cloud, and 5 phone service provided by Google. Please keep in mind one important point as well. So, if you have a project that is not linked to an active, valid cloud billing account, you will not be able to use the products and services enabled in your project. This is true even if your project only uses Google Cloud services that are free. So your project should be linked to an active billing account in order to use those services. Now let's have a look at some of the important billing roles that we have in GCP. So 2 major roles are billing account admin and billing user. So if you're not sure about the role, we will be discussing that in detail in the IAM section of this course. But for now, just keep in mind that a role is nothing but a set of permissions which defines what level of access the user has. The user with the role billing account admin can create a billing export to the BigQuery. He or she can view cost and spends, set budgets and alerts, and also can link and unlink the projects with the billing account. However, billing user role has limited permissions such as they can link projects to cloud billing account but they cannot unlink them. So this is the major difference between billing account admin and the billing user role. Alright, now let's go ahead to the console and see the billing account in action. So I'm in my Google Cloud Console over here, and if you click over here to the drop down where it says projects, so I have 4 projects currently, and this project and this project, my first projects, these 2 projects are attached to the billing account. However, project A and project B are not attached to the billing account. So we'll see what is the difference between those, and how we can attach these two projects as well to the billing account. So I'll just keep that as selected and hit open. Now in the search window, I'll search for billing. I'll go to the billing account, right? It says this project has no billing account. So I'll click over here, link a billing account, and it shows me one option, my billing account. And this is the default billing account that's get created when you create your Google Cloud account. So I'll select this one and set account. Once you do that, this particular billing account gets attached to the project, right? And all your project costs and credit will be accumulated in that billing account. So the billing account is here. This is my billing account. This is the unique ID of that billing account. And from here, you can manage the billing account. So if I click over here to the manage section, now it shows all the projects that are linked to this billing account. There are 3 projects. My first project, this one and this one, and project A that we have just added. If you want to delete any project link to the billing account, you can do that by clicking on the 3 dots over here and do disable billing. And then you can close the billing account as well from here. Let's see the difference between the projects that has billing account linked with them and the project that doesn't have the billing account linked with them. So this project, we just linked it. So that means we will be able to use its services. So if you click on any of the service, let's say Compute Engine instance, it will show you the dashboard and you can click on create instance, and basically you can use those services. However, if you go back and select the project that is not linked to a active billing account, which is project B, if I select that and let's go to a GCE service, I'll search for GCE Compute Engine, and it says enable API. I'll enable the API. And now it says Compute Engine requires a project with the billing account, and enable billing or cancel. If I do cancel, it won't let me enable the API to use the service. So the only way to use the Google product and service by enabling the API and by enabling the billing account. Without billing account, we cannot use any of the services, right? So you can enable it from here as well, or from the billing account like we have enabled for project A. So let's do this. Now it will ask you the same thing, the billing account that you want to be linked with this project. I only have one billing account, the default one. So I'll select that and hit set account. So let's go to billing from here. On billing. And if you click on manage billing account from here, now you'll see all 4 projects are linked with this billing account. So now let's go to the billing account again. I'll select the billing. We have different options over here. So the first one is overview, where you can see your total cost incurred and your forecasted cost for next month based on the previous spend. Then we have cost trend and other auto generated dashboard widgets. Then we have report section over here, in which you can basically create the report based on the filters that you select. Like you can select based on current month, last month, or last 90 days. And you can group it by a project, service, or hierarchy. And you can select the projects that should be part of this report, or if you want to exclude any project or any service. And you can also add labels to it, and then report will be generated for you, right? For example, in my report there are only 2 services used in past 90 days, Cloud Logging and Compute Engine, and the cost was this much, but then it was part of the free trial, so it was deducted from the promotion balance that I had, and the subtotal was 0 for me. The same way we have cost table, which will give you the cost report in another format. Like this is the project that has the cost incurred with it. So if I expand it, it will show the services for which the cost was incurred. So EC2 instance in Americas, it was this much, and this instance had this much of cost associated with it, and so on. So all the services would be visible over here, whatever I have used, including the persistence disk. Okay, and the total would be presented over here as cost, and this was the credit. Subtotal is here. Okay, the same way you can generate report from here as well. From the right side there are filters. Then we have cost breakdown. This is the breakdown of cost among usage cost, promotion, subtotal, and total. And then we have few other fields, and this one is again an important one, budgets and alert. In order to avoid any surprises on your billing, you can create budgets and alerts so that you will be notified when a charge exceeds a certain amount. So to create a budget, hit over here, create budget, give it a name. Let's call it test budget. Range, let's put monthly, select all the projects, select all the services, or you can customize it. Hit next. Select the budget type, specific amount, or the last month spent. Let's say if you want to be notified if the cost is greater than what was there in the last month, then you will get the budget alert. Or you could just specify amount. Let's say for me, I'll just set $10 per month. Hit next, and then it will generate the alert for you based on the threshold that you set over here. So the first notification will be triggered when it reaches 50% of the budget utilization, which is $5, and it will trigger on the actual cost, not on the forecasted cost. You can choose between those. The second notification will be triggered when the threshold will pass 90%, which is $9, and the third notification will be triggered at 100%. You can customize these values as well, or you can add a new threshold value from here, and you can select the type of notification that you would want to receive, like the email notification, which is by default selected for you, or you can connect to a PubSub topic as well. You can subscribe to a topic and push the alert there, and you hit finish once you verify everything. So this budget and the alerts associated with it are set now. Right, you can update whenever you want and however you want. Right, so this is the limit over here, $10 for July that we have set. Okay, so this is how you can set budgets and alerts. Another important thing is billing export. So you can export your billing data to a BigQuery data set. Right, these are the steps of how to do that. I will be covering that part in the BigQuery section of this course. But for now, just keep that in mind. If you have to do any analysis on the billing data, you export it to the BigQuery and perform the calculation over there. Identity and access management has three important aspects: authentication, authorization, and accounting. Authentication takes care of who has access to your GCP resources. Authorization takes care of what level of access the authenticated user has, and accounting on which resource the user has access. Let's talk about authentication. A user is referred to as a principal, and it could be a Google account or cloud identity user, a service account, a Google group, or a Google Workspace domain user. Let's talk about authorization now. Certain permissions can be granted to a principal with the help of IAM roles. A role is nothing but a collection of permissions that determine what operations are allowed on a resource. When you grant a role to a principal, you grant all the permissions that the role contains. So this is how authorization works. There are three types of IAM roles in GCP: basic or primitive roles, predefined roles, and custom roles. Let's have a look at each of those. Basic roles are referred to as primitive roles, and these are owner, editor, viewer, and browser. It provides a really broad level of permissions and they are not recommended. In addition to the basic roles, IAM provide additional predefined roles that gives granular access to specific Google Cloud resources and prevent unwanted access to other resources. For example, if you are using compute.instance admin role, it would have certain permissions such as compute.instance list, compute.instance get, compute.instance delete. So when you are using this particular role, all the permissions along with it will be inherited and you cannot alter the behavior of this role. You cannot add or delete permissions from it. Right? So you have to use it the way it is. These type of roles are created and maintained by Google, and Google automatically updates these permissions as necessary, such as when Google Cloud adds a new feature or service, then these roles would be updated. If you need something even finer grains, you use custom roles. So these roles are created to tailor permissions to the need of organization when predefined roles does not meet the needs. For example, if you would want to grant only instance list and get permissions to a specific set of users, you create a role something like this, and then you just add those two permissions to it, and you can use the custom role. Custom roles cannot be applied at folder level. Let's talk about IAM policies now. A policy is nothing but a collection of a role binding and metadata. Each role binding can include the following fields: a principal, which we have already seen. This could be a member or identity, which can be a user account, service account, a Google group, or a workspace domain user. Role binding also has a role, which is a named collection of permissions that provide ability to perform certain actions on Google Cloud resources. Then it could have a condition, which is an optional logic expression that controls when should the access be granted to the principal. Metadata contains fields such as e-tag and version details. The important part to remember here is policy applied at the parent level inherited from top to down. For example, if you want to grant your principal access to all the projects in an organization, then you apply the policy at the organization level, and all the projects inside that organization will inherit that policy. Let's see an example of IAM policy. So this policy is with condition, which is also referred to as a conditional policy. Here we have created a role binding for a principal, which is this over here. We have applied the role to this particular policy as a security reviewer, and we have added the condition as this. So as part of this condition, if we look at the expression over here, if the request time is less than 1st of July 2022, only then this policy would be granted. If this particular member tries to access the resource as a security reviewer after this date, then the access will be denied. And these are the metadata fields over here, which is e-tag and version. Now let's have a look at the service accounts. Application uses service account to make authorized API calls. Service account does not have passwords, and that is why they cannot log in via browser or cookies. A service account can be attached to a compute engine VM so that application running on that VM can authenticate as the service account. In addition, the service account can be granted IAM role that let it access resources such as cloud storage. The service account is used as an identity of the application, and service account's role control which resource the application can access. Service account is identified by its email address, which is unique to the account. Let's have a look at the IAM best practices. While implementing identity and access management, you should always apply principle of least privilege, which restrict your users or application to not do more than they are supposed to do. You should always avoid applying roles directly to the users. Instead, you should use IAM groups. You assign the roles to those groups and add users to those groups instead of assigning roles to each user separately. To give someone temporary access to the project, you should create a temporary account in the cloud identity. You should use audit logging, which helps you answer certain questions such as who did what, when, and where. So basic or primitive roles are not recommended to be used. So I have logged into my Google Cloud Console. From the left navigation menu, you search for IAM and admin, which is over here. I'll click on that. So there are few options available over here. First one is IAM. From here, you could set your permissions, roles, and everything. So you can check all the principals. So these are the principals. So this one over here, the first one, it's a default compute engine service account, which got created when I created my first compute engine. Then we have Google API Service Agent service account. And this one is my user account. So there are these type of principles over here. And if I click on roles, so these are the basic roles that we see. Currently, I am the owner of this organization. So I am by default assigned to the owner role. And the two service account that we saw are part of editor role. Right. So these were the basic roles. Then the second option is identity and organization. Currently, I don't have any organization setup, so this won't be visible. But over here, you could see the organizational hierarchy. Okay. Then you could use the policy troubleshooter to see if certain user has access to certain roles. Right? You provide their principal email over here, the resource and the permission. Right? And you check the API call, it will provide you the details whether that particular principal has access or not. Then we have organization policies. So these are the default organization policies. Then in service account, you would see your compute engine default service account. And over here, there are the roles. So these are all the predefined roles, and custom roles will also appear over here. Right. So if you want to create a new role, you click on that, create role. You give it a name, let's say custom role test. A unique ID will be generated for that. Let's call it custom role hyphen test. You select in which launch stage you would want to make this role as available. Let's just keep it default alpha for now. Then you assign permissions to it. So these are, you see, 5,971, all the permissions that a principal could have. So you can filter these permission by predefined roles. So you select it, then select any role. Let's call it, let's search for compute engine. So I'll select this one, compute admin role. If you select that and click OK, so all the permissions that are there as part of compute admin role, so there are 601 permissions, all those would be presented to you and you could select either of those. There are some permissions which says supported or testing. That means these are in alpha stage right now and they are not ready to be used for production system, and you won't be getting any GCP supports if anything breaks on these services. So you should use this cautiously, right? So let's say I use address create, address get, address list. Okay, just for the example. So I'll selected these and hit add. Right, so these three permissions are assigned, and then hit create. When you do that, a role would be created. Now you see the other roles that you see had a different icon because these were predefined role, but this role is a custom role, and custom roles are donated by this particular icon. So if you want to see, let me zoom it a little. So you see the icon is little different than what we had before. So let's quickly have a look what exactly is a cloud storage. It is a service for storing your objects in Google Cloud. And what are the objects? Well, an object is an immutable piece of data consisting of a file of any format, typically the unstructured data or the binary large objects. Objects such as audios, videos, images, archives, etc. These type of unstructured data are typically stored into buckets, and then the data can be accessed by different users or GCP service using different authentication methods such as IAM roles or pre-signed URLs, or these objects can also be public. So we'll have a look at all those in detail. So cloud storage is suitable for many use cases such as storing and accessing unstructured data such as audio video files, binary large objects, images, and it can also be used to serve static website, the video streaming data. It can also be used to store your backups and archives for disaster recovery or for regulatory and compliance purpose. Logs and other reporting data can also be stored in the cloud storage. So let's have a look at another important concept of storage classes. So whenever you create a bucket, you specify the type of storage class that bucket belongs to, and all the objects inside that bucket will inherit that storage class unless it is specified otherwise. So it defines the object's availability and pricing model. It also defines how fast the requested data can be retrieved from the bucket. So there are four type of storage classes that GCP support: standard storage class, nearline, cold line, and archival. Let's see the differences between all those four. So first is data access. So the standard storage class is used to store the frequently accessed data. Nearline storage is used to store the data that is infrequently accessed, typically once a month. Cold line storage stores the data that is also infrequently accessed, but even less frequent than nearline storage, such as once a quarter. And as the name suggests, archival storage class stores the data which is accessed rarely after it's been created, typically once a year. So there is a minimum storage duration that you should be aware about before storing your data in either of these storage classes. Standard has a very small duration because it is frequently accessed data, and it should be typically stored for a brief duration. You store data for a minimum of 30 days in nearline storage, minimum of 90 days for cold line storage, and for archival storage, you store for at least 365 days. Let's see the cost associated with each of these. So because standard is used to store the frequently accessed data, so the cost when it comes to retrieving or storing the objects, the standard has the highest cost. Nearline has the lower cost than standard but higher than cold line. Cold line has lower cost than nearline but higher than archival, and archival has the lowest cost. So all four of the storage classes support dual or multi-region. When you create a bucket and specify a storage class, you could select whether you want it to be regional, dual regional, or multi-regional. Each of those would have different costs associated with it. Obviously, multi-region would be the highest, and then dual region will have a lower cost than multi-region, and the regional cost will be the lowest among all those. So you choose that strategy as per your use case and as per the criticality of your data. Then let's have a look at the use cases that they are ideally suitable for. Standard should be used for use cases such as serving web content or streaming videos that requires the application or the user to frequently access the data. Then nearline for reports such as auditing profit and loss. So those reports that is usually accessed once a month. Cold line storage is typically used to store backups, snapshots, logs that is accessed like once a quarter. And in archival, we store the data for auditing, legal and compliance purpose, or if it needs to be used as part of the disaster recovery process. So this type of data is typically used once a year. All right, so I have logged into my Google Cloud Console. I'll just go to the navigation menu and search for cloud storage, which is over here. I'll click on the service and then I'll hit on create bucket. So first we have to provide this a unique name. Please pick a globally unique name and it will be a permanent name. That means you cannot change the name once you have created it. So I'll give this a unique name. Let's call it tutorials with Piyush 101. Right, I'll hit continue. Then it will ask me the location type, whether it should be multi-regional, dual regional or regional. So each of these have a different cost structure. So if you see the multi-region is 0.026 per GB per month because it will be hosting your bucket in multiple regions in US. If you choose the regional one and select a region, let's say I'll select this one which is nearest to me. So it will cost you 0.023 per GB per month. So there is a difference between multi-regional, dual region and regional costs. Right? So I'll just select the regional so that I could use the minimum possible cost. I'll hit continue then. Then it will ask me to choose between different storage classes. If it is a frequently accessed data that is used for a short-term storage, then I'll use the storage as standard, as nearline or cold line. Archive storage we use for storing the long-term archive. Typically that is accessed once a year. Okay, so I'll just keep it default for now, which is standard. Then there is an option which says enforce public access prevention on this bucket. So by default, this is publicly accessible. So if I check mark this box, that means this bucket is now private and would not be available publicly. Then you specify the access control, whether you just want it to be accessed by the bucket level permissions or you want to specify access to the individual objects using the object level permissions. So I'll just use the default, but make sure you understand the difference between those two. The first one would be at the bucket level, the second one would be at the object level. The next is how to protect the object data. By default, the protection is none. You select the object versioning when you want your multiple versions of data to be stored. Let's say you upload a file and then you updated it. So if the object versioning is not enabled, the previous version will be replaced by the newer version. But if we select the object versioning, both the versions will be kept and you can use the previous version whenever you want to roll back the changes. So it'll ask you few different things like maximum number of versions per object. So let's say we want to keep it at least 2 versions of the object, expire non-concurrent version after 7 days. So it'll keep 2 versions for at least 7 days and then it will delete the previous version. Then there is one option which says retention policy. So we can prevent the buckets object to be deleted or modified before a specified number of days. So you can enable this option as well. And you can choose the data encryption, whether you want to use the Google managed encryption key, or if you have your own key, you can use that as well. So after verifying all the details, after entering all the details, and after verifying the price, I'll just hit on create the bucket. So the bucket is created. This is the bucket name. If you want to check, go back and you see one bucket has been created just now, which is a regional bucket created in this particular region. So I'll just go inside the bucket. Then there are different options. First, let's go ahead and upload some files to this bucket. I'll upload this image. Okay, so the image is uploaded over here. And these are the details of that particular image or the object. You can download it by clicking over here. You can edit the metadata, which is the content type, right? Or the custom metadata you can add. Then you can also delete the object from here. This is the preview of that object if the preview is supported, right? The object is not public because we have created the bucket as private. That is why this object inherited the policy. And if we go back, now we see different options as well. First is configuration. So configuration is your buckets configuration that we have created, right? So all the options that we have selected while creating the bucket, you can change few of the options. Few of them are auto generated and few of them you cannot change, such as the URL of the bucket you cannot change because it was auto generated with the predefined format. And you cannot change the region of the bucket or the name of the bucket once it is created. Then if we go to the permissions, it says it is not public, it is a private bucket, and we haven't created any ACL for that particular object. Then we have protection. We have enabled the bucket versioning, and that is why it is showing as enabled. And if we go to the life cycle, this is another important concept. So lifecycle management consists of a set of rules that you apply to a bucket object when certain conditions are met. For example, you want to delete the object after 30 days to save the cost, and you know that you won't be needing these objects after 30 days. So you could just set the lifecycle rule instead of manually going and deleting each and every object after the 30-day period has been passed. So let's see how we can add a rule. It already has two rules. If we see, let me collapse this, because we have enabled the object versioning. That is why it created the rule which says it should have two new versions, and it would delete the previous version when 7 days has been passed after the version become non-current, right? So these two rules were created as part of that. Create a new rule, you use this option, add a rule. So there are different actions that you can select. Actions are of three type. You can change the storage class from standard to nearline, from standard to cold line, or from standard to archive. Or you can delete the object, or you can delete the multi-part object. So multi-part object is something that was uploaded in multiple parts but hasn't finished yet. So it will not delete the finished multi-part but only the unfinished multi-parts. Right? And important thing to remember over here is you can only change the storage class going in the upward direction. That means from standard to nearline, or from nearline to cold line, or from cold line to archive, right? But you cannot go in the backward direction. Like you cannot change the storage class from archive to standard or from archive to cold line like that. Okay. So this is how it should be. So once you select an action, let's say I want to change the near line, then you specify object condition, which means when the rule will be triggered. Let's say you want to change the storage class after 30 days, right? So I'll click over here to the age condition. I'll specify the number of days as 30. So now the action that we specified was to change the storage class from standard to nearline. And the condition that we have set is age is greater than 30 days, right? So when I click continue and create, now it says the action is set to nearline and the object condition is 30 plus days since the object was updated, right? So this is how you can create a rule and it will be automatically applied to all the objects in this particular bucket. Now let's see how you can access the bucket using the command line. So I'll just open the Cloud Shell from here. Let's say I would want to download an object. So first I'll clear it. And now I need the object's GS URL. So I'll just go to the object and I'll copy the URL that starts with GS, right? This is the URL generated for GS util. So I'll just copy the URL and I'll type the command gs util copy and the object location which we have copied and the directory in which we would want to download the file. So I'll choose the current directory. Once I hit enter, it will prompt you to authorize or reject the call. So I'll just authorize it. And once I do that, it will just download the file. It says copying this particular file to this location, which is my current directory. So if I do ls over here, I will see the file has been downloaded, this one. The same way we can upload the file from here to the bucket. Let's see how we can do that. So I'll again use the same command gsutil test.txt and I'll enter the gsutil URL. I just need the bucket URL until here. Copy it. I missed the CP after gsutil, so gsutil CP. And then source file name and location and then destination location. I'll hit enter and it uploaded the file. It says operation completed. So if I go back to my bucket, I should see the test.txt file. To delete the objects in the bucket, you select the object, hit delete, and then delete it. So it has deleted the objects now. Because there was only one version of the file, that's why it deleted the files completely, even though the versioning was enabled. If we had the multiple versions, then it would have kept the non-current version. Okay, so if I go back to my bucket now, I don't have anything. So to delete the bucket, I'll just select the bucket and hit delete. It will prompt me to enter delete just to make sure that it is not an accidental delete of the bucket, because once the bucket is deleted, it cannot be recovered, right? So exercise caution over here and hit delete. Let's see few of the cloud storage best practices as recommended by Google Cloud. So you should always apply the principle of least privilege when it comes to authentication and authorization. That means restricting your users or application to not do more than they are supposed to. You should not make the objects as public unless it is required. So if the objects are used as part of video streaming or a content if the objects are used as part of a video streaming or a content serving service, then it can have the public read-only access. You should use the object lifecycle rules to manage the cost. Bucket versioning should be enabled for critical data so that it can be recovered in case of a disaster or any accidental deletion. You should use signed URL to share the bucket objects with external users or the unauthenticated users. You can also set the expiry of the URL to even strengthen the access control. And you use parallel composite uploads to upload larger files using GSUDL. A block storage is a type of storage which emulates the behavior of a physical hard drive. These data disks are stored in blocks and are attached to the compute. In Google Cloud, it means they are attached to compute engine or a Kubernetes engine, which is GKE. Then we have a concept of persistent disk because a block storage can be persistent or non-persistent in nature. A persistent disk is a high performance block storage that uses solid state drive, which is SSD, or a hard disk drive, which is HDD. And you can attach multiple persistent disks to compute engine or GKE simultaneously. The other difference between persistent and non-persistent disk is data stored in the persistent disk can be retrieved even after the instance is stopped, rebooted, or if it is crashed. The data will still be there. However, with non-persistent disk, it doesn't comes with these capabilities. Once the instance is stopped, the non-persistent disk attached to the instance loses all its data. Compute Engine offers several type of storage options for your instance based on your performance and pricing requirements. So we have 5 different options to select from. So first one is standard persistent disk. So these are backed by standard hard disk drive, which is STD, and are lower in performance. And rest 4 are backed by SSD, which is solid state drive, which is high in performance. Because standard persistent disk is backed by STD, it is recommended for the workload that requires standard throughput. Balanced persistent disk provides a balance of cost and performance and offers lowest cost per GB. Performance disk SSD or PD SSD provides lowest cost per IOPS. The recommended workload for extreme persistent disk are SAP HANA, Oracle, these types of application in which uncompromising performance is needed. Local SSD are basically used as hot cache for database and real-time analytics purpose. So standard persistent disk is the most cost-effective solution, and the recommended use cases are big data and big compute workloads. Balanced persistent disk is an ideal choice for running your standard enterprise applications. And performance persistent disks are recommended for performance sensitive workload. Extreme persistent disk guarantees highest performance among all those persistent disks. And local SSDs guarantees lowest latency for your application. So first 4 storage options that we have are backed by persistent disks. They can be used as a bootable disk. You can install operating system on these type of disks. And these provide the capabilities of zonal and regional replication. However, local SSDs are ephemeral storage, that is, they are not persistent in nature and it cannot be used as a bootable disk. It does not provide zonal or regional replication capabilities. VPC network is a logically isolated network on Google Cloud Platform. You can think of a VPC the same way you would think of a physical network, except that it is virtualized within Google Cloud. A VPC is contained in a project, which again is a part of Google Cloud Platform. Each VPC network consists of one or more IP range called subnets or subnetworks. For instance, US West one could have one subnet, which is subnet 1, and US East one could have 2 subnets, subnet 2 and subnet 3. Subnets are regional resource and have IP addresses associated with them. For example, over here, if you could see, subnet 1 has this IP range and subnet 2 and 3 has their own IP ranges. Please make sure you select the IP ranges carefully. If you like to know more about how to calculate IPs in a subnet range and what is a subnet mask, then feel free to check out the video that I published for the same. I will put the link in the description section as well as in the title bar. Also, you can use this online tool. I'll put the link again in the description section, and there is a utility called subnet calculator along with it, so you can just put in your IP range over here. Let's say our subnet 1's IP range, which is 192.168 1.0, and we have selected the subnet mask as /24. So here it is, you can select any subnet mask. So again, this calculation, how you can calculate it manually, I have given in the video that I was talking about. /24 will have 256 IP addresses. You can select any other range as well. And when you enter it, just hit calculate. So it will populate the IP range for you. The first address being 192.168.1.0 and the last one would be 192.168.1.255. Even though it says it has 256 IP addresses, but there'll be few IP addresses in this range or in every CIDR range that is reserved by Google Cloud for future purposes. So please make sure you understand that as well. Okay, so this is the way how we can check our IP range. All right, so we have selected the IP range of all three subnets. If later on the IPs get exhausted, because you see each of these range that we have selected would have 256 IP addresses. Let's say in future at some point of time you would need more IP addresses to a particular subnet or one or more subnet. You could just edit this subnet or any subnet and extend the range. Let's say currently it is /24 mask. You could just edit it to have more IP addresses /23 subnet mask you can use, or anything less than that. It will give you more IP addresses. Just keep in mind you can only extend the IP range, but you cannot delete it and you cannot shrunk the IP addresses. Now, when you provision a compute instance, you select the zone in which it must be provisioned, and the region that you select for a resource determine the subnet that it can use. So in this example, when you provision two GCE instance in zone US West A, it determines that the region is US West 1, and this US West 1 region has only one subnet with this IP range. So these two instances will have the IP in this range. Let's say it could be 192.168.1.5 for this instance, and for this instance it could be 192.168.1.12. So this is how the IP will be selected for these two. Similarly, when you provision instances in US East 1, they will be part of subnet 2 and subnet 3, and they have the IP from that CIDR range that they are part of. If you are confused about the difference between zone and region, so just keep that in mind, that zone is nothing but a collection of data centers in a geographical location, and region is a collection of multiple zones that are located miles apart. But why do we need region and zone separately? So we deploy a workload in multiple zones and regions to attain high availability and fault tolerance. So let's say we have deployed our workload in this region as well as this region. Let's say due to some natural disaster or anything, this complete region goes down, then your application will still be available through this particular region. So this is how we have attained high availability and fault tolerance with deploying our workload in multiple regions. So after you create a network, you can create firewall rules to allow or deny traffic between resources in the network, such as communication between VM instances. You also use firewall rules to control what traffic leaves or enter the VPC network to and from the internet. Firewall rules are defined at VPC network level, but you can associate it with one or more instances. There are two types of rules. You can create an inbound rule or an outbound rule, which is also referred to as ingress or egress rules. Inbound, as the name suggests, restrict the inbound traffic on a certain port from a certain source or from the internet. And the same way, outbound restrict the outbound traffic on a certain port to a certain destination. By default, there are two implied firewall rules created, one which allows all outgoing connections and another that denies all incoming connection. Again, these two rules have the lowest priority of 6535, so you can easily override these rules by creating a lower priority rule, let's say 65400, and this rule will be evaluated first and then this rule be evaluated. So let's say this rule has allowed the outgoing connections with this particular priority, right? And you want to deny that rule. So you could just create a deny rule with this priority, and this rule evaluated first and the connection will be denied. This rule would not even be evaluated. But you can just override these rules by creating a lower priority rules, and you cannot edit or delete these rules as these are implied rules. By default, instances on a same VPC can talk to each other with their private IP. So these all instances can talk to each other using their private IP. They don't have to access their public IP because they are within the same network. Like every instance has the connectivity with each other. But you can also create a firewall rule to deny the connection, let's say between the instances of subnet 2 and subnet 3. Now there is another important thing, which is VPC routing. VPC routing defines the network path that packets take to travel from source to destination. Any incoming traffic, like what is the destination of it, what would be the next hop, how it will traverse from one location to another, right? And how would the outgoing traffic would go from one location to another. So this all will be defined with the help of VPC routing, and entries would be created in route table for the same, right? We will have a look at this routing in the next video where we'll be discussing about VPC peering. Let's head over to the demo and see everything in action. All right, so let's head over to your Google Cloud Console and search for VPC networks over here. You click on that and you will see there is a default VPC already created for you when you have provisioned your project. And you will also see there are subnets created in each of the available region over here, right? So this is what a default VPC does. It by default creates the subnets in all the regions that is available, and they have a unique IP range. You could use this VPC as well, but there is a caveat to it. If you have an on-prem server, or if you are planning on connecting your on-prem server in the future with this particular project, or if you have other VPCs or you will be creating multiple VPCs, then there is a chance that these IP ranges could overlap with your other IP ranges. So this default VPC and default subnet range are good for your learning and POC purpose, but it is not recommended to run your production workload. So this is the default. Click over here, create VPC network. Once you do that, you could just give it a name. Let's call it my VPC. Description, this is not a mandatory field, so you could just leave it blank as well. And then if you scroll down, it says subnet creation mode. So there are two type of creation mode with VPC, custom or automatic. If you select the automatic mode, then again it will do the same thing. It will create subnets in each of the available regions, which is what we don't want. And you can choose the custom mode as well. So with custom mode, you could add your own subnet. There is no subnet created for you. So you could just click on new subnet, give it a name. Let's call it subnet 1. Select the region. I'll select the same region, US West 1 and US East 1 for the other one, US West 1. There is a IP stack mode. So subnet works in both the modes, single stack or dual stack. Single stack, it'll only have the IPv4 address range, and for dual stack, it'll have IPv4 and IPv6 range as well. So for now, I'll just select the single stack and provide the name that we have already selected, 192.168.1.0/24. We'll have 256 IP. We could additionally create secondary IP range as well. Done. So our first subnet is there. Let's create second subnet, subnet 2. This time I'll select the region as US West 1. I'll give the IP range as 10.1.0.0/24. Done. And I'll create my third subnet as well. Region is again US West 1. We can create more than one subnet in a particular region. One is already created by default if we are using the automatic mode, but because we are using the custom mode, there was no subnets created automatically. So 10.2.0.0/24. All right, I'll click on done. Right, so we have specified 3 subnets to be created. Now firewall rules. So there are some default IPv4 firewall rules created for you. First one is the ingress rule, which allows incoming connection from all the IP ranges that we have locally. So these are all the private IP ranges that we have set. That means all the VMs within our VPC will have incoming connection between each other on all the ports. Again, the priority is the lowest. You can override this priority if you want to deny any access. Then second one is ICMP, allowed from outside the internet. That means anyone over the internet could ping your instance. Anyone could RDP your instance if they have the keys, and anyone could SSH to your instance if they have the login credentials. And then we have a VPC deny all access. That means all other ports are denied other than these that have been specified, because you see the rule priority is the lowest. First, these rules will be evaluated, which has the higher priority, and then these two rules will be evaluated. So this will deny the access on all other ports that have been specified. So this will just deny the access on the ports that have not been specified over here. And then there is a egress allowed. That means instances within your VPC can connect to the internet. Then I'll just leave these fields as default and hit on create. Now this will create a VPC. It will take a couple of minutes. If you go down, your VPC is getting provisioned. So I'll just pause the video till it's getting created. All right, my VPC has been created now. So you see, this is the VPC and 3 subnets have been created with the IP ranges that I have specified. If we go to my VPC, it has all the details. So with VPC, it comes with another few components. So it'll have some static internal IP if we have reserved it. If not, you can reserve it from here. This is just like Elastic IP in AWS. We have static external IPs as well in GCP. So you could just reserve static internal or external IP and associate with any of your instance. Then we have routes over here. So it has a default local route to the subnet so that the instances can communicate with each other. So there'll be 3 routes for that. And there is one route to the internet so that all the instances within our VPC can communicate to the internet. And these all details will look in the later sections when we cover VPC network peering. So we have firewall rules over here. Because we did not selected any of the default rules, that is why it's not there. Only the implicit rules will be applied, which is not visible. So we could just add the rule from here, add firewall rule. Okay, let's give it a name, allow SSH. And the network is my VPC network. That is fine. This is a type of ingress rule and action should be allowed. Then you specify your target tags. Let's give it a tag. Let's call it dev server. So this rule will be applied to all the servers that have a tag called dev server. I'll show you how it will match it. Then it has IPv4 ranges. So source IPv4 ranges, let's give it to everything. Then allowed on a particular protocol, let's call it TCP port 22 so that I should be able to SSH to it. And that's it. Just verify everything and hit create. All right. So now you would see the firewall rules created over here. If you expand this, this is allow SSH rule, which is an ingress rule. As I've mentioned before, firewall rules applied at VPC network level, but you can associate it with one or more instances. So now let's go to our GCE compute engine and provision a GCE service. Hit on create instance. If you are not familiar with GCP, I have also created a video for that. So feel free to check that out. I'll again put the link in the description section as well as in the title bar. So let's call it test VM 1. I use the default zone. I use the small machine type, something like E2 micro. And then I'll go down. So the rest of the section, I'll just keep it default for now. And the main is this one, advanced option, and that networking. Okay, here you mention the network tag. So I'll just mention dev server. Then you select the network interface, which is the default one attached to it. So you select the network, my VPC. This is the custom VPC that we have created. And then you select the subnetwork. Now you see, this is what I wanted to show you. It says no subnetwork in this region. So you don't have anything and it is grayed out. You cannot select. This is why, because we have not created any subnet in US Central 1 region, right? So this region, if you remember, I've told you if we select the zone, it will determine the region based on that. And based on that, it will determine which subnet the instance should be part of. But because we don't have anything in this particular zone or region, that is why it is giving us the error. So let's just select region as US West 1, Oregon region, and zone is US West 1A. Okay, and now if you scroll down, you see it auto populated the subnet 1 details. Okay, so that's it. You click on done and hit create. All right, our VM has been provisioned. And if you see the internal IP, this is within the range that we have selected for that particular subnet. So let's click on the VM and do SSH into it. So it is transferring the SSH key to the VM and establishing the connection. Right, I am in. Let's clear the screen and do ping on google.com. I'm getting the reply from google.com. This is because there is a default route to the internet gateway, and this is what we wanted to test. Google Cloud VPC network peering allows internal IP addresses connectivity between two VPC networks. Those VPC networks could be from same project or organization or from different projects or organizations. There is no restrictions to that. Traffic remains inside the Google backbone network and don't traverse through the public internet. There are some advantages of using network peering over external IP addresses or VPNs to connect networks. First one is network latency. Connectivity that uses internal IP address provide lower latency than external IP addresses as there are no hops or devices between the peering connection. Service doesn't need to be exposed to the public internet and deal with its associated risks. So it provides a greater network security for your workloads. By using internal IPs, you are saving egress communication cost. So yes, it is a cheaper option than external IP connection. Now let's see how peering works. Consider an organization which needs VPC network peering to be established between network A in project DR and network B in project prod. For VPC network peering to be successfully established, administrator of network A and network B must separately configure the peering association from DR to prod as well as from prod to DR. VPC A has one network subnet, with CIDR range as 10.0.0.0/16. Similarly, VPC-B has one subnet with CIDR range as 10.8.0.0/16. Make sure that the participating VPCs in a network peering should not have the overlapping CIDR range. Otherwise, there will be a conflict and connection would not be established. Each subnet has a Google Compute Engine, which you would want to connect via their private IP addresses. Let's call them VMDR1 for VPC-A and VMProd1 for VPC-B. From VPC-A, you create a connection and enter the project and network you would want to peer with, in this case, which is project prod. In VPC-B, you import and export custom routes and create the peering connection. This connection will be created from DR to prod. At this point, the peering state remains inactive as there is no matching configuration in network B in project B. A network admin or a user with appropriate IAM permission in project prod must configure the matching configuration from project DR in order for the peering connection to be active on both ends. You follow the same step from VPC Network B to create the connection from prod to DR, and as soon as peering moves to an active state, subnet routes and custom routes are exchanged, and both VM will be able to talk to each other via their private IP addresses. Let's see another example. Over here, VPC A and VPC B are already peered. We created a new network, VPC C, and wants to peer it with VPC B. Now, VPC peering cannot be established in this case as well. You see there is a CIDR range overlap between VPC A and C. It has 10.0.1.0, it has 10.0.1.0. Even though we are trying to peer VPC C with B, but VPC A also is a part of this active connection. So that is why you cannot create the connection between these two as well. Let's have a look at the transitive peering now. So we have three VPC networks, VPC A, VPC B, and VPC C. If VPC A is peered with VPC B and there is an active connection between those from both the ends, and if VPC B is also peered with VPC C and there is active connection between both these VPC, that doesn't mean that VPC A and C are automatically peered. So there is no connection between those two VPCs, and this is what we call as transitive peering. So transitive peering is not supported in Google Cloud Platform. Let's have a look some important points with respect to what we have seen so far. Subnet CIDR range overlapping is not allowed if you wish to peer the networks. Transitive peering is also not supported. You could have a maximum of 25 connections to a single VPC network. That means one VPC could only be peered with 25 other VPCs and not more than that. This is the limitation. To delete a VPC network, you should first delete all the peering configuration in the network and then you can delete the VPC network. Otherwise, it will not allow you to do that. And you would need compute.network admin role or the editor role to create or delete the VPC peering. VPC network peering only works with Compute Engine, GKE, and App Engine flexible environment. Other services are not supported because these are the only services that you provision inside a VPC. All right, to follow the steps that we have seen so far, I have logged into my Google Cloud Console and I will be creating two separate VPCs in two of the projects that we have. So first, I'm in my project DR. I'll search for VPC network. Click on Create VPC Network. I'll give this a name, VPCA. Then I will create a subnet, call it subnet A, and then I'll select the region as US East 1. Now I'll specify the IP range of this particular subnet. So let's call it 10.0.0.0/16. It'll have 65,000 something IPs, and done. Then I'll select two default firewall rules. One is ICMP, another one is SSH, so that I could SSH into my instance that I'll be provisioning in this VPC, and I could ping the VM from the another VM. Okay, and then keep everything as default, hit create. Now I'll open a new tab and create the VPC in the other project that we have, which is project prod. So click over here in the drop down and select the other project. Okay, now search for the VPC network again and create a new VPC network. Give it a name, VPC-B. Create the subnet in custom mode. Subnet name is subnet B. Region is, earlier we chose US East 1. This time we will be using US West 1. Over here, specify the IP range 10.8.0.0/16. Please make sure that IP range is not overlapping with the other IP range that we have in VPCA. So that's why earlier we chose 10.0.0.0/16. Now we are using 10.8.0.0 so that they don't have any overlapping IPs. Okay, done. The same way we will be using ICMP and SSH default firewall rules. Keep everything as default, hit create. And if we go back to our VPCA and scroll down, our VPC has been provisioned. Now I'll create a instance in this particular VPC. So search for compute engine, create instance, give it a name, VM1DR. Select the region as US East 1 because that is where our subnet has been provisioned. Right, US East 1. I'll choose a smaller machine size, E2 micro. Scroll down to the networking section. Over here, advanced options. Expand this and hit networking. Scroll down a bit and you will see your default network interface. So you again click the drop down and change the network from default to VPCA. Okay, and the instance will be created in the subnet that we have created, and keep rest of the thing as default. Hit done and create. Now let's follow the same step in VPC-B, which is in our next tab. So let's quickly verify VPC-B has been created. It's there. So search for compute engine, create instance, give it a name, VM2 prod, and specify region as US West 1 because in this region our subnet was provisioned. Change the machine type to micro. Scroll down to the networking section and change the default network to VPC-B, and it will auto populate the subnet for you. Done, and create the instance. Now our both the instance in two separate projects and two separate VPCs have been created. The first one is active. Let's log into this. The internal IP is this one. So this is what we're gonna use for our VPC peering. But first let's see how the instance see each other without the peering, right? So I'll just SSH into this VM. All right, I'll clear the screen and let's grab the private IP from the other instance. So this VM is also ready. So I'll just grab the private IP from here, which is 10.8.0.2. Copy this. And I'll go back to my SSH window, which is over here. I'll try to ping the prod instance from the DR instance. This is the private IP. Hit enter. and I'm not getting any reply even though the ICMP port has been enabled, right? Because there is no connectivity between both the instances, as there is no connectivity between those two VMs, as they both were provisioned in two separate projects and two separate VPCs, right? So if you see 100% packet loss, there is no connectivity. Now let's go back to our project DR and create the VPC peering connection. So for that, you go to VPC network and go to VPC network peering over here on the left side. Now create a connection. Says you will need the following info: the project ID if you're connecting to another project, and name of the VPC network that you want to peer with. I'll show you how you can do that. Hit connect, give it a name. Let's call it peering DR to prod. Select the source VPC network, which is VPC A, and the peer VPC network is in another project. So choose this one in another project and specify the project ID. This is not the project name, but the project ID. So I'll go to the drop down again and I'll grab the project ID from here. This is the project ID of our prod project, right? So I'll copy this, paste it over here, and the VPC network name. Our VPC network name was VPC-B. I'll import custom routes as well as import subnet routes and export it as well. Hit create. Maybe I'll hit refresh. Okay, so the peering connection from DR to prod has been created, but this is just the one side of the connection. You still need to create the other connection from prod to DR. That is why it is showing as inactive currently, right? So I'll go to my project prod, search for VPC networks, and I'll create a new VPC network peering. So you hit create connection, continue, give it a name, peering prod to DR. Select your source VPC network, which is VPC-B. Select the destination VPC peering network, which is in another project, and I'll grab the project ID from here. I need the project ID of project DR. Okay. VPC network name of the destination VPC is VPC-A. I'll select all these options to import and export custom routes and subnet routes with public IP. Hit create. So now the connection is showing as active, and if you go to the other VPC that we have from DR to prod and hit refresh, this connection is also active. So once the connection is established between DR and prod, two VPCs, the custom routes will be exchanged and it will be created automatically. If you go to routes, and if you could just filter this by network VPC A, right? So you see three routes have been created. One is default route to the default local route to the subnetwork, the destination of your subnet, and then there is a default route to the internet so that this instance could talk to internet. Another one is route to the peering connection, which is in our prod project, right? And the destination IP is 10.8.0, right? The same way, if you see, the routes will be created in this VPC as well, routes, and filter it by the network name. Network name was VPC-B, and the same way three routes will be created over here. Now let's go back to our GCE instance, compute instance, and SSH to the terminal. Okay, let's ping the instance again. And now we are getting reply from there. That means we have successfully peered our VPC connection from DR to prod, and this will work for other way around from prod to DR as well. Let's have a look at another important concept, which is shared VPC network. So when you use shared VPC, you designate a project as a host project. Let's name it test env and attach one or more service projects to it. So UAT env and performance test env, these two are our service projects. A shared VPC admin for the organization has created a host project and attached to service project to it. There is a shared VPC connectivity between these projects. Eligible resources from service project can use subnet in shared VPC network. Service project UAT env can be configured to access all or some of the subnets in the shared VPC. And admin has created an instance in UAT1 in the zone US West 1 region, and this instance receives its internal IP address 10.0.1.5 from the subnet 10.0.1.0 subnet A. The same way, admin has created another instance BT1 in US East 1 region, and the instance receives its internal IP 10.0.4.8 from the CIDR 10.0.4.0/24. Shared VPCs allows an organization to connect resources from multiple projects to a common VPC network so that they can communicate each other securely and efficiently using the internal IP of that network. However, shared VPC only works for same organization. It won't allow you to connect the project from multiple organization that was there in VPC peering. So these two instances can now talk to each other via their private IPs, because those two private IPs have been created in the shared VPC network and there is already a connectivity between those. So this is how shared VPC network works. And you could have multiple host projects in an organization. So this is our test network, like what we have seen so far. You could have another network, which is prod network, and you could share it with your other service projects. However, each service project can only be attached to a single host network. So this DR env is attached to this host project over here. So this cannot be attached to the test network. This is the limitation. Not everyone wants to maintain the infrastructure, set up networking, manage application scaling, and other operational and administrative tasks such as server patching and upgrade, and just focus on writing code. But how would you ignore these important factors and just focus on your code development? Well, App Engine to the rescue. You might be wondering what exactly is an App Engine? Well, it's a fully managed serverless platform as a service for developing and hosting your web applications at scale. You can choose from several popular languages, libraries, and frameworks to develop your apps, and let App Engine takes care of provisioning servers and scaling your applications based on the demand. You don't have to worry about managing the infrastructure and you can just focus on writing your code. It is well suited for a microservice based architecture. Now let's understand what exactly is a platform as a service. PaaS, or Platform as a Service, is a cloud service offering in which Google Cloud or any cloud service provider basically takes care of your infrastructure such as runtime, middleware, operating system, virtualization, servers, storage, networking, all these aspects. And you can just focus on your application and data. Well, there are two types of app engine environment. One is standard, another one is flexible. Let's have a look at the difference between each of those. Well, in standard deployment, your application run on a sandbox in its own secure, reliable environment that is independent of the hardware, operating system, or the physical location of the server. And flexible, your application instances run within the Docker containers on compute engine virtual machines. Standard comes with pre-configured runtime environment of a supported version of below languages only: Python, Java, PHP, Node.js, Ruby, and Go. Only these languages and few particular versions of these languages are supported. And if you want to use any other programming language, then Flexible would be a better choice for you, where you could just use your own custom runtime or source code written in any other programming language. Well, there is a free daily quota in app service environment, and it is a pay-per-use service. In this particular version, you can scale down the instances to 0 to save some cost. However, in Flexible, the pricing is based on usage of compute resources such as CPU, memory, disk, and instances cannot be scaled down to 0. The minimum you can bought it down to is 1. In standard, you don't have the SSH capabilities. If you want to perform the SSH to the underlying virtual machine, then again Flexible would be a better choice for you. Standard is mostly suitable for the applications that experiences sudden and extreme traffic spike, where immediate scaling is the requirement. However, if you have an application that receive consistent traffic, experience regular traffic fluctuations, then Flexible would be a better choice for you. So there is a limited third-party binary installation. For standard, you cannot install your third-party binaries other than the versions and languages provided to you that we have already seen. In Flexible, there is no limitation to that. You can install any third-party binary. There are 3 scaling types supported by standard app engine: manual, basic, and automatic. However, with Flexible, we have manual and automatic. Alright, so this is our sample app.yaml file that is used as a deployment configuration file for any app engine deployment. Over here, you have specified your runtime. So I have used Node.js 16. You could use any other supported version if it is a standard deployment. If it is a flexible deployment, then you can use basically any version or any other programming language as well. Here, the instance class is F2, default is F1. If you don't specify the instance class, so default will be F1. So F1, F2, F4, and basically all the F classes supports auto scaling. However, all the instance classes that starts with B, like B1, B2, B4, P8, they support manual and basic scaling. Auto scaling is not supported in the B class. It's only supported in the F class. Here you can specify your environment variables. This would be the default bucket where your application engine code will be uploaded and downloaded during the version deployment. And this is the handler section where you have specified, like, if the URL is this, like, look for this particular directory and download all the static files from there. This handler is basically redirecting all your HTTP traffic to HTTPS with the response code 301. This is the error handler where all the default errors will be redirected to this page, and error code such as over quota will be redirected to this page. So this is a simple structure of a app.yaml configuration file. Now let's have a look at the different scaling types in App Engine. We have 3, as we have just seen: basic, automatic, and manual. So you specify basic scaling as this block in your app.yaml file, where the max instances would be the maximum number of instances that your version will be scaled to. In automatic scaling, you basically specify the metrics according to which you would want your application to be scaled. You specify min and max instances and few other optional parameters as well. In manual scaling, you only specify the instances. For example, over here we specified instances as 5. So this would be the initial number of instances that will be provisioned, and it will be scaled accordingly. Now we have 2 more parameters to be used in app config file: max idle instances and min idle instances. So maximum number of idle instances that are warmed up to be used when application needs scaling. So this is to enable the rapid scaling as the load increases on the server, and minimum number of instances that are warmed up to be used when application needs scaling. Right? So these two are again the optional parameter that can only be configured if you have enabled inbound services warmed up. Right? So you need to put this block in your app YAML in order to use the above two parameters. Let's have a look at the example now. Let's suppose you have application A. In your project A, you could only have one application per project. Then you could have multiple services as part of that application. Let's say service 1 and service 2. Each service could have multiple versions. Whenever you deploy a service or you redeploy it with a new option or you update anything in that, a new version will be created. And you could choose to split traffic among the previous version and the new version, or you could just migrate the traffic as well. You could roll back from one version to another. We'll see that in the demo section. And each version could have multiple instances serve the traffic. The version 1 is running on instance 1. However, version 2 of service 2 is running on instance 1 and 2. Let's say we have a scaling event happen and application needs auto scaling. Then new instances will be provisioned and the load will be distributed accordingly. So this is to make sure that you have high availability and fault tolerance whenever there is a spike in the traffic. Once everything is done, follow these steps to perform the resource cleanup. Please keep in mind you cannot delete an app engine once it is created, but there are different steps you could take to stop incurring charges. First, go to application engine, disable the application. Then you delete the default App Engine service account. Then you delete the App Engine storage buckets. Alright, so let's log into your Google Cloud Console and search for App Engine. Right, if you don't have anything created yet, it will be like this. Then you hit over here, create application. First step is to select a region. Region change is permanent. You cannot change the behavior after this. So let me just use the default region, which is US Central. Hit next. Now it will ask you to choose the language and the environment type. We have these many options to choose the language from: Python, Node.js, Java, Go, PHP, .NET, Ruby. And if you select any other language than this, then this option, the environment option, will be changed to flexible, because only flexible has the capabilities to use any other language than the provided ones. Right, so I'll just use the Node.js one in the standard environment. Right, and the next step is to create the App Engine deployment from your Google Cloud SDK or from the Cloud Shell. So you could just download the SDK on your local system, or you can use the Cloud Shell. I'll just activate the Cloud Shell where this gcloud SDK will already be installed, and I basically have to run this command, gcloud app deploy. But before that, I need to have my repository ready. Right, so I have downloaded the source code over here, Node.js sample docs. If you want, there is this GitHub repo which has some code samples that you could use. So I'll just go inside this directory, App Engine, and there are different examples. I'll just use the hello world. Okay, and standard deployment. So in this, I have an app.js file which will be serving as my web page, and there is this app.yaml. So app.yaml that we have already seen the syntax of it. App.yaml will have the configuration that is used by your App Engine deployment. So currently it only has the runtime, but you could also add the other options that we saw. Right? Okay, this app.js will have a hello world page, will print Namaste Google Cloud, and it will listen on port 8080. Right? So to deploy the app, there was this command over here, gcloud app deploy, and you need to just run the command over here. It's not this one, gcloud app deploy. Once you do that, it will prompt you to authorize the request. Hit authorize. And it will show you the different details like your project name, target URL, version, service account. So App Engine default service account will be used. Hit continue. Yes. Now it will upload these files to a Google Cloud Storage bucket. Alright, it has deployed the application. Okay, and it will be listening to this particular default service. You could either run this command to get the URL or just open this in a new tab. Paste it over here. And it says Namaste Google Cloud. So our app has been deployed successfully. Now few things over here. Let's go back to our cloud console. Now if you refresh this page, you will see a default service created over here and one version listening to it. So this is like if you go to versions, this is the version that is currently enabled and serving 100% of your traffic, right? Let's say you want to deploy a new version of application. Okay, let me make some change over here. app.js, and let's change the welcome message to Namaste Google Cloud 2.0 over here. I'll save the file. Let's redeploy again. Google app deploy. Yes. Okay, it will again upload the file to a cloud storage bucket for the newer version. Alright, so a new version will be created now. Let's go ahead and refresh this page. Okay, Namaste Google Cloud 2.0, our version has been deployed now. Now if we go back over here and hit refresh on the versions page, you will see two versions. And this newest version is now serving 100% of the traffic. But you can always roll back to the previous version. You select the version that you want the traffic to be rolled back to, and you hit over here, migrate traffic. Once you hit migrate, your traffic will be routed to the previous version. So this will become 100 and this will become 0. So let's wait for a few seconds. It will just doing that. Hit refresh now. Now you see the traffic is now serving back to the previous version. Right, let's open this in a new window, and now you see Namaste Google Cloud, which is our version 1. Now you can also split the traffic in percentage between those two versions. To do that, select the versions, hit over here split traffic, right? Select the split traffic by field, by IP address, by cookie, or randomly. Let's use this random, and let's put like this particular version 7.7 will receive the remaining traffic, and this receive 50% of the traffic. So you select over here 50% to this service and rest 50% to this version. Let's hit save. Okay, now it will split the traffic randomly between those two versions, version 1 and version 2. Okay, it says split successfully saved. Let's go to versions now. You see 50-50%. Let's open a new incognito window, paste it over here. So this was our version 1. Hit refresh. Namaste Google Cloud 2.0, that is a newer version. This is the older version. So you hit refresh and it will keep on changing the redirection of traffic from one version to another. See, this is version 1. Hit multiple times, and this is version 2. Okay, this is what we wanted to test it out. So this is one way of splitting the traffic. Another way is to split the traffic by that gcloud command itself. Online, I'll put the link in the description section how you could split the traffic during the deployment itself, which is also known as canary deployment, right? The next thing is, so we have seen This is the dashboard where you will see all your summary of the request and responses to this particular service, your billing status, your current load, how many requests were there, and stats based on that. And here will be your services. Currently we have two versions of the default service. Then your versions details over here, instances, right? There is only one instances right now for this version, and for this version there is two instances. This is how the traffic is getting splitted between those two. Then we have firewall rules. I guess this is the basic one. Okay, once the app engine application is created, you cannot delete it, you could only disable it. And let's see how to do that. You go to settings over here and disable application, enter the app ID over here. Let me just copy it and remove the space, hit disable. This will just disable the application, so that will start incurring cost. And if you see at the version, now these are in the stop state, but again you will be still charged for the storage that you have used. So go to storage bucket for that, cloud storage, and just delete these buckets that was created by app engine. So this is the default bucket, staging and app serving traffic. Delete all these, delete, delete it. Then go to IAM and delete the app engine default service account, which is this one. Remove access. Like most of the GCP resources, Google Kubernetes engine can also be created using all those different methods, like from the Cloud Shell, using gcloud commands, using the API calls, or from the Cloud Console itself. So as part of this demo, I'm going to create it from the Cloud Console. So let's hit search on GKE and Kubernetes engine. This is what we need. And if you are using this service for the first time, it will ask you to enable GKE API as well as Compute Engine API. So those needs to be enabled before you start using it. So because I've already used it before, that is why it's not showing me. Now I can hit create to create my first Kubernetes cluster, and it is showing me two options to create the cluster. One is autopilot, another one is standard. In autopilot GKE, Google takes care of all your node provisioning and administrative tasks. You don't have to worry about anything, and you need to pay per resource that you use. But in standard Kubernetes cluster, you pay per node. You takes care of all your node provisioning, and you set up auto scaling based on your workload. So I'll just select standard cluster so that we could see all other options that are available within GKE. So configure on that. And now the first thing is it's asking me to provide it a name. Let's call it test cluster. Then we select how we want this GKE cluster to be hosted, like whether zonal or regional. If we select zonal, we need to specify in which zone we need it. But if we want our cluster to be highly available and fault tolerant, we use the regional option where we select the region and it will deploy your Kubernetes cluster in multiple regions. Your control plane will also be hosted in multiple zones. But if you select zonal, your control plane will be hosted in one zone. If the underlying node is down, your cluster will be down, right? So choose this option wisely. Then you select your control plane version, whether you want to provide a specific version or you select the release channel. So these release channel, there are different releases like rapid channel, regular channel, stable channel. You could select the release type and select the version based on that. Now you could just hit create over here to create your cluster with all the default settings, or you can customize all these over here. So let's go to default pool. Over here, the first option is node pool. Node pool is nothing but collection of different nodes, or in this case, GCE virtual machines grouped together in a pool, right? For example, if you want to have your nodes created on Linux Ubuntu based system, and all of these should have, let's say, 32 gigs of memory and 12 vCPUs, then you create a node pool with that configuration, and all the nodes that gets created in that node pool will have the same type of resource configuration, right? So our first node pool is the default one, and here is the size of nodes. The number of nodes it will have is 3. Cluster autoscaler adds node whenever your workload require more nodes, and it will delete the nodes if the resources are underutilized. Right, so it will take care of all your auto provisioning of nodes, and you can specify minimum and maximum number of nodes as well. Deselect this option for now, and you can select your node location as well. For example, I have just used a zonal cluster. That is why there is only one location selected, but you can change the behavior and then it will become a regional cluster. And then it says automatically upgrades node to next available version. Will keep your node up to date to the cluster's control plane version. So whenever there is an upgrade to the control plane, your node will also be upgraded to the same version. And when we are using a release channel, these options are automatically enabled. And this takes care of your auto repair. Whenever there is a issue with the node, it crashes or it changes the underlying host, it will auto repair that node for you. When there is a surge in your system, so let's say when there is a maintenance activity such as cluster upgrade, node upgrade, then it will add additional nodes to the cluster so that your workload will not be impacted. And the number of nodes it will add is 1 because we have specified max surge as 1, and max unavailable is 0. That means there is at least one node running all the time to serve the traffic. Next is node. So this is the configuration of your default node pool, right? Image type, and then machine type, machine family, and then boot disk type, all those things. That's part of your GCE configuration. If you go to networking, you can specify the maximum number of ports you want per node, right? The default is 1110 for this particular version that we have selected, but you can change this behavior as well. Then if you go to security, it says use the compute engine default service account, because your all the underlying nodes are nothing but GCE VMs, right? So it will use the GCE VM default service account, and you can specify your access type. Here is the metadata. If you have to add any taints to the node or any labels that you would like to specify, you can do that as well. You can enable the maintenance window. Maintenance window will be the time frame or the timeline in which your scheduled maintenance activities such as cluster or node upgrade will be performed. You can enable it and provide a timeline, like do it weekly at this time, from this time to this time. Or if you do not select this, then upgrades will be performed anytime it feels suitable. Then you can enable vertical pod auto scaling. Vertical pod auto scaling is nothing but it will automatically resize your pod based on the CPU request and memory request. And then we have an option enable node auto provisioning. That means it will create or delete more node pools as the workload demands. Then this is the networking, how the cluster will be created, which subnet, and whether it will be a private cluster or a public cluster. If we choose a private cluster, then only internal IP addresses will be assigned to pods and the nodes. It will not be accessible outside from the control plane. So this is the better choice if you are using it for your production or your organization workload, right? And you can enable the control plane access as well, like only my organization CIDR range would have access to this cluster. So you can specify your CIDR range as well. Like for this demo, I'm just using the public cluster. You can enable workload identity or Google Groups RBAC, all those things. Then this is the metadata field, like we see in node pool. This is cluster level metadata. And features is if you want to enable cloud logging and monitoring, by default it is enabled. So let me just disable it. So this will let you have some insights into the cluster. All the logs and metrics will be captured, and you could just query it from the Google Log Explorer or Metrics Explorer. And there are a lot more options. Some of them are in beta. That means it is not released for the production recommended setup, but you can still use it. And once you verify everything looks great, you hit on create. All right, as we can see that our cluster is ready now. and it has 3 nodes, total vCPU is 6, total memory is 12 gigs. It says low resource request because I haven't provisioned anything on this cluster yet. So I'll go inside my cluster by clicking over here, nodes. So it has one default node pool, and these are the 3 nodes that are part of this default node pool. If you would like to see any of these nodes, you click on the node and it has these pods running. So these are just the control plane workload that was provisioned with the cluster, and all the details such as resource request. So because we disabled the logs, it is not enabled, but you can enable it and it will be visible over here. And this is the YAML for this particular node, right? It has all the details. To enter into the cluster, what you can do is go back to the cluster, right? This is our test cluster, and over here you see a button which is connect. Click over there, and basically this is the command that you would need to run to get inside the cluster. Gcloud container cluster, get credential, and then name of the cluster, zone, and the project name, right? Either you could copy it or run it directly in the Cloud Shell from here. So let's do that. Okay, I'm inside my Cloud Shell and this command was pasted for me automatically. So I'll just have to hit enter and it will ask me to authorize it. Hit authorize. And I'm logged in. So let's clear the screen. Let's clear the screen and run a kubectl get pods. Right, it says no resources found because it is default namespace. So let me provide the namespace as kube system. Right, these are all the pods that are running inside this cluster. Now let's see how to perform a test deployment of a sample Nginx image. So I'll go over here on the 3 dots and I'll click upload. I have a YAML file already created in my local machine. So choose file and I'll select the file, right, and hit upload. This file will be uploaded in my Cloud Shell. Over here, if I do an ls over here, nginx YAML, maybe I need to replace the name nginx.yaml. Let's do a vi on that now. And this is my deployment YAML. So it has 2 replicas of nginx image and it will be using 1.14.2 and running on container port 80. Right, I'll just get out and now we can run kubectl. Let me clear the screen first. Now we can run kubectl apply -f and nginx.yaml file to apply the deployment. Right, it says deployment created. Let's do a kubectl get deploy and it is updated. All the pods are up and running. So if we go back to our cluster and go inside the workload, you will see our Nginx deployment is running. If we click on that, you can see other details like these are the 2 managed pods and it is not exposing any service. So that is it. Running Nginx container, just 1 container per pod. And over here are the details and events, logs. We have disabled it already. And over here you see the YAML file that we have just used. It will also have some metadata because we have deployed it. Now, when we want to update the deployment, what we can do is like from here as well, we click and edit the deployment, just make the changes over here and hit save, or we can do it from the Cloud Shell itself, like kubectl edit deploy nginx. It was nginx deployment, right? So you can make the changes and save the file. It will be done. Let's update the replica from 2 to 3 and save the file. Once you do that, it says deployment edited. And now if we go back to workload and just wait for a couple of seconds, hit refresh, and you see 3 pods are there. The changes will be effective immediately. Right? So this is how you can update your deployment as well. Now, there'll be a time when you have more than one cluster running and you would want to set a default cluster. So to do that, let me just exit from this Cloud Shell and open a new shell now. And then you run this command, gcloud config set container / cluster and the name of the cluster. When you do that, your default cluster container will be set to test cluster. Right? This command is also really important from the exam point of view. Gcloud command we use when we need to create the cluster, delete the cluster, or interact with its configuration. However, we use kubectl command when we need to interact with clusters, control plane, or workload, or any Kubernetes component. Well, the first question you should ask yourself before choosing a database service in GCP is whether your data is structured or not. See, structured data is something that has a predefined structure. Files such as JSON, YAML, log file, or any text file for that matter of fact, these are considered as a structured data. However, your static files such as your audio files, your video files, images, these are all your unstructured data. So if your data is not structured, if it is unstructured, then the next question you should ask is whether you need mobile SDK capabilities. If yes, then cloud storage for Firebase would be the best database service for your use case. If you don't need these capabilities, then cloud storage would be the best suitable database service for you. So I have created a separate video for cloud storage. I have discussed everything that you need to know about cloud storage. Link in the description as well as in the title bar. Also, like this service, if you are new to GCP, cloud storage is similar to AWS S3 or Azure storage, right? So I guess you get the idea now. What is cloud storage? This cloud storage for Firebase just adds some mobile SDK capabilities on top of cloud storage. All right. Now, let's say your data is structured. Now, you should be asking whether you need data analytics capabilities. If you need low latency database, then Cloud Bigtable would be the suitable choice for you. Well, Cloud Bigtable is a NoSQL column-wide database optimized for heavy reads and write. So if you need those capabilities, then please go ahead with Cloud Bigtable. If you don't need low latency database, then Cloud BigQuery would be the better option for you. Well, BigQuery is a data warehousing solution for large amount of relational data. Right? This is not a NoSQL service. This is a relational service, but it is an ideal use case for data warehousing where you can run SQL based queries on your data sets to get the required results. Let's say if your workload is not analytics, the next question you should ask is whether your data is a relational data or not. Well, what exactly is a relational data? Any data in the form of rows and columns is a relational data, right? And we manage and maintain relational data with the help of a relational database management system. If your data is relational data, then do you need horizontal scalability? If not, then Cloud SQL would be the better choice for you. Cloud SQL is a general purpose SQL database. These all services are managed, so Cloud SQL is also a managed service, and it is cost effective when compared to Cloud Spanner, as it doesn't support horizontal scalability and auto scaling, and it supports SQL engines such as MySQL, PostgreSQL, and SQL Server. Right, all these are managed services supported by Cloud SQL. Let's say you need
The capabilities such as horizontal scalability and auto scaling in case your workload unexpected and it grows as per the demand grows. So use cases such as gaming is an ideal choice for Cloud Spanner because you don't know when the traffic will be high. There could be unexpected spikes in the traffic on the server. So Cloud Spanner will be a better choice for you. This is again an expensive option, but it comes with some extra capabilities. Cloud SQL is used for general purpose SQL database needs. Now, let's say if your data is not relational, that means it is NoSQL data, that is in the form of key value pair or data in the form of columns, documents. All these type of data are NoSQL data, and if you need the capabilities of a NoSQL database, then you should be checking whether you need mobile SDK capabilities. If yes, then Cloud Firestore for Firebase would be an ideal choice for you. If you don't need these capabilities, then the next question you should ask yourself is whether you need in-memory database for faster caching and faster performance for frequently queried data. If yes, then memory store would be a better choice for you. Memory store comes with Redis and Memcache and provide multi-millisecond latency to your workload. But if this is not a requirement for you, then Cloud Data Store would be an ideal choice for you. It is again a managed NoSQL service that can store and manage your data so that you could get the maximum performance out of it. Almost every organization spend a lot of their resources in analyzing the cost incurred by them. In other words, they analyze the billing data to get insights about the cost and for reporting purpose and for making the future forecast. But how do you do it in GCP? Well, in GCP you can run BigQuery. BigQuery is a managed data warehousing solution that lets you run SQL queries on your data to get meaningful insights from it. It has a scalable distributed analysis system that returns the query results within seconds for terabytes of data and within minutes for petabytes of data. And as it is a managed service, you don't have to worry about your infrastructure. So let's head over to Cloud Console and see how you can analyze your billing data and all other type of data. So I'll just go to my Cloud Console and search for BigQuery. So this is my default project, which is I'm currently using. This is my query editor on the right side. So when you expand the project, it has a default external connection, right? So you can create your new data sets over here using these three dots. Click over here, create a data set. Okay. The project name is the default one. Let's give it a name, test Piyush 1. And the data location, you can select multiple locations for high availability, or let's choose US East 1. You can enable table expiration because this will create the temporary table that can be cleaned up after a certain number of days to save some cost. So let's just put number 1, and rest option you can leave it default, create the data set. This is as simple as that. And when you click on the data set, it will show you the details. Now you can create a table inside this data set. Again, click on these three dots, hit create table, and the source you can specify whether it should be an empty table. That means you will be entering your data manually, or you have this data somewhere stored already, like in Google Cloud Storage or some drive or big table, or even AWS S3 or Azure Blob Storage. So let's select Google Cloud Storage. I have already uploaded a sample CSV file which we can use in this demo. But again, you can export your billing data and use that. I'll show you the other option as well. So please be with me till the end of the video. So I'll select the file from here, click browse. This is my bucket, and then this is my sample CSV file. I'll select this file and it auto detected the file format as CSV. Now, destination project is also the same project. This is my dataset name in which I'm creating the table, and you could also create a new dataset if you want, but we have already created. Give this table a name. Let's call it sample data. And there are two options
in table type, native table or external table. So native table is table will be created in BigQuery itself, but when you choose this option external table, it will just create the metadata in BigQuery and the source table will be referred every time the data needs to be analyzed, right? So this will also save some cost if the data is huge in the external table. So just external table option would be sufficient for you, right? Then it can auto detect the schema as well. And if you click on advanced options, you see it auto populated the field delimiter as comma because we have uploaded a CSV as the source data, and header rows to skip. So we have one header inside that CSV with the name of the fields. So I'll just skip that row and that's it, and just hit create table. All right, so I'll just close this. Table has been created over here, sample data. If you click on that, you will see it auto calculated the schema for you, right? These were the fields inside that table with type string, integer, and the rest of the default values. Then if you see the details, all the details that it has, like number of rows and even the size of the table. Then if you click on preview, this is all the data that we have inside that table, right? So it will just convert that data to show you the preview, and you can run queries on it. So you can just click over here. You can create the query in a new tab, or you can split this tab as well. Let's use a new tab. All right. So if you do select star from, so this is the simple SQL query format. So the format of accessing the data would be something like this. First is the project name, then we have the data set name, and then we have the table name, right? So it will be selecting this data from sample data table, from project this, data set this, and the sample data. So let's, because we only have 10 records in that, so let's just use the limit as 5 and run the query, right? It will show you results over here. We have 5 results and the header row was excluded from the result. It also shows you different details as well, such that the JSON format of this table output, the execution details, how much time it consumed for the execution, how much read and write it did, and everything. And the same way execution graph will also be shown over here. Now you can save this result as well in again a Google Drive, a local file, JSON, CSV, and all other options we have, or even a BigQuery table, right? So this again, the results that we just got from here from running this query, this will be created in a temporary table, right? This table will be deleted once we close it. So this is the result from the data that we have already in our cloud storage, but we can also query the public data sets that are publicly available. For example, let's close this. Okay, and close this as well. All right, I'll just expand this. So over here, you can search the public data. I'll provide you the link in the description from the Google Cloud Docs from where we can get the sample public data sets. So let's say we have a public data table called GSOD. If you search, okay, it will not show you any results because currently it will search in your project only. But you can click over here, broaden search in all projects, and the results will be shown to you because this particular table was part of a different public project, right? So this is the project name, BigQuery public data. This is the data set, and these are the table names. So let's select this table and then we can run query again. Like let's see in a new tab. Let's do a select star from this and put the limit as 10 and run the query. Okay, it will show you all the results over here, right? And you can apply any condition as you want, like the where clause, order by, group by, everything would work just fine as in a SQL query. Also, you can join one or more tables from the public data set to get the results. So let's use this query. For example, it will get these two fields from both the tables. So over here, we are selecting these two fields from these two tables, GSOD 1929 and GSOD 1930 from the same data set.
and we are joining based on this field, and we are just limiting the records by 10. If you run it, it will show you the results as intended. So again, this data will be created as part of a temporary table inside BigQuery, and it is referring the data from the external data sets that is publicly available, right? This data set over here. So yeah, this is really important to understand this from the exam point of view as well as from learning the BigQuery perspective. You can also create a billing export which will send the data asynchronously to BigQuery, and you can run analytics on that. So to do that, you go to billing export. Let's just leave this. All right. So it has different option like standard usage cost, detail usage cost, what type of data set you want to generate. So this will be generated and updated daily with the cost details per SKU, right? And it will export the data. So once you enable it, I haven't enabled it now, but you can just do this, edit settings, and create the data set over here. Let's say test123, save it, and you create the same data set in BigQuery. So it will take some time and your data will be exported in real time from the billing to the BigQuery. Let's quickly have a look at the pricing for BigQuery. It comes with two main components. One is analysis pricing, another one is storage pricing. So first one is cost that you incur when you run your SQL queries, your user defined functions or scripts, and certain DML and DDL statements that scan your tables. And the storage pricing is the cost to store data that you load in BigQuery. And along with that, it has two different pricing models. One is on demand pricing, another one is flat rate pricing. With the first one, you charge for the number of bytes processed by each query, right? All the reads that it gets from the query. And the first 1 TB query processed per month is free. So with the flat rate pricing, you buy the slots, which is the number of virtual CPUs that you would want to use to execute your queries and run analytics. You can use a 60-second slot, a monthly slot, or an annual slot, and the prices will be different for each of these slots. After you have deployed your application to your live production environment, the job is not done yet. There are a lot of tasks that you would have to perform regularly to ensure the high availability and scalability of your applications. An organization proactively engages its resources in setting up its operations and maintenance to avoid any last minute chaos. But how would you exactly do that in Google Cloud? Well, cloud operations to the rescue. Now you might be wondering, what is this cloud operations, formerly known as Stackdriver? Well, it's a suite of applications running on Google Cloud that can help you monitor and troubleshoot your infrastructure and applications. The tools includes monitoring, logging, and advanced observabilities such as Trace, Debugger, and Profiler. These tools provide deep insights and best practices that help your organization utilize Google SRE principles. Let's have a look at each of these tools. Cloud monitoring provides visibility of health across your apps and infrastructure, regardless of where it is, using metrics and dashboards. Using Metrics Explorer and Monitoring Query Language MQL, you can analyze these metrics and create alerts and notifications. Uptime checks and SLO monitoring is also an amazing feature of monitoring. You can even define custom metrics unique to your use case and send them to external system for further analysis. Cloud Login aggregates log data at scale from all of your infrastructure and applications into a single location. This enables user to search and analyze large volumes of logs to troubleshoot problem quickly using Log Explorer. It also gives you the capability to create log-based metrics and set alerts on them. You can even create log syncs to route logs from one location to multiple supported destinations such as tables created in BigQuery datasets, pub subtopics, cloud storage buckets, and another cloud logging bucket. Advanced observability feature trace provides insight into request flow, service topology, and latency issues in your app, which can help improve the application latency and increase performance. The profiler performs a dynamic code analysis and continually analyzes your code's performance on each service so that you can improve its speed and reduce your cost. The debugger allows you to inspect running applications after deployment without needing to stop or slow down by taking snapshots of variables and the call stack and injecting debug log points in your running application. Please note that the debugger is officially being deprecated and support will be provided by GCP until May 2023. It's been officially replaced by an open source tool called Snapshot Debugger, which pretty much does the same thing. Now that we have seen cloud operations, what it is, and what are the tools that are part of it, now let's head over to Google Cloud Console and see logging and monitoring in action. Please pay attention to this particular part as I will be covering some important topics that could come in your Associate Cloud Engineer Certification exam. Let's have a look at the logging first. So I'll search logging over here and go to the logging tool. Now, once you open it, this is the default view that you'll get. On the left side, you'll see your resource type over here, and on the right side, the preview of log entries. Currently, it's been set to show the last 1 hour of log. You can change it from here and you can select as per your needs. Let's select last 30 days of logs. You can enter your custom range as well. Okay, hit apply. Now that I have broadened the horizon, it will show you a lot of logs and lot of resource types as part of it. Let's have a look at each of those. So if you see the resource type could be VM instance, Kubernetes cluster, BigQuery, firewall, all the resources for which logs are available during this duration will be visible over here. Then we have the severity level of the logs, debug, default, info, notice, error and warnings. When we are doing some troubleshooting, when we need to check if there is any error, we basically check these two type of severities, error and warnings. Now over here as well, there are different filters that you could use. First is resource type. So these all resources that were visible on the left side, you can select it from here as well, and from the log name as well. So log name is again a type of filter. Now there are different type of logs in GCP. Logs such as activity log, data access log. Activity log could be something like when a particular user was added to the project, or who added the user, what is the principal username of that user. All those details will be logged under activity log. Now when there is any manipulation on data that happened, it would be logged under data access logs. And the same way, there'll be different type of serial output logs, application logs, and many other types. I just want to check when was the last time a user was added to this project and who added that user and what was the user ID of the added user, right? So I can filter the query using the activity log. It is a type of activity log. Hit apply. Then you notice over here, it will generate a filter over here. So the value is of type activity. And this is basically the log name. And the results are over here. Now, based on that, I could change the duration as well. Let's say I just want to check in last 3 hours, last 30 days. It's fine. Now there are lots of entries over here. The other filter that we can apply is resource type. So let's add the resource type as Google project. So you notice something like whenever I click over here, it auto generated the filter. So you can add filters from the left side as well as from this drop down as well. It's one and the same thing. Or if you know the value of that particular filter, let's say you just type label, it will show you all the different values available for that. You select one of those and provide the value. So now that I have used the log as activity and resource type as project. This is only one result. It happened today. It says the method was set IAM policy. That means IAM role has been added to the user, and principal email who added the user was this. Let's have a look at the JSON payload. If you go to service data, you would see type as audit data, and then go inside policy delta, binding deltas, 0, and you will see the action was add on the user tutorials with piyush@gmail.com, and this role was added. So this was the activity that was performed at this particular time. This is how we can check when a user was added to the project, who added it, and how it was done. Now we want to see all the data access that happened in this project in last 30 days. So again, we can just remove this. We select the log name as data access log, hit apply. So the filter is generated now. And over here, you will see all the resource type are mostly BigQuery, because this type of log, data access audit log, we have to explicitly enable it for a particular resource. For BigQuery, it's enabled by default and you cannot turn it off. That is why we are only seeing the BigQuery logs. All the operations that we did on data was logged over here. So for example, let's say there was this job insert happened. So who ran this job and who created the log entry was logged. So once we have the data, like whatever data we need, we can download it by clicking over here. It will ask you whether you would want to download it in JSON or CSV format, maximum log lines, or if the log entries are more than 10,000, then you can export your logs or create a sync as well, right? So to create a sync, let's go over here, logs router. So whenever you do any operation in your cloud project or any type of log is generated, by default it will be streamed to this default bucket over here, and you can customize what type of logs you would want to export to this required bucket. So these two are the default log router syncs created for you, but you can create your own sync if you want to transfer your data from one source to another supported source. Create sync, give it a name, test, select the sync service destination. So destination could be, as we have seen before, BigQuery dataset, cloud logging bucket, storage bucket, pub subtopic, or we have another option which is Splunk, or you can export it to other project as well. Right? Let's select anything for now. Cloud storage bucket. You browse the bucket from here. Currently, I don't have any bucket, so that is why it's not visible. But you can create one if you want, and then you can choose what logs to include in the sync, and you can create an exclusion filter as well. Once you create the sync, these logs will be synced in near real time to that destination, and you can run all type of analysis, and you can store these logs for long term archival purpose as well, right? So this is how you can create the log syncs. Then we have log storage. Again, this is showing the usage of these two buckets, and it says log analytics available, and you can upgrade it to store more type of logs. And here are the retention period of that. And over here, you can create log based metrics. You can hit create metrics and then select the type, whether it is a counter metrics or distribution metrics name, and you apply the filter over here. So it uses a query language to build the filter for you. You use that and you create the log based metrics. Now let's go to monitoring now. This is the default page for monitoring. And if you are using it for the first time or you haven't used it very much, then this would be screen presented to you something like this, and it will ask you to install the ops agent. Ops agent is nothing but the primary agent responsible for collecting telemetry data from your compute engine instances, and it uses fluent bit for logs, and it collects logs as well as metrics. So you can install ops agent from here. Click on setup agent. It will show you the instances in which the agent is installed or not detected. You can select that and install or update agent. If you click that, it will generate a command for you that you could run in Cloud Shell, and it will basically install that agent for you. Right. So I'll just hit cancel for now and go back to the overview dashboard page. So it's asking you to perform few things. First is integrate with Google Cloud Service, then install an agent, create a dashboard. So there is already a default dashboard. Then you can create uptime check or an alert. So now let's go to metrics scope first. So with Google Cloud Monitoring, you could monitor more than one projects. You could add the project to the metrics scope, right? From here, currently there are two projects. One is monitored project, another one is scoping project. Hosting project is the project, my current project, that is hosting the monitoring service. And monitored project is the project that is being monitored along with the first one, right? So project dr would have visibility inside project prod, but not the other way around, right? So you could add more projects to this metric scope by clicking over here. Let's say I have two more projects. I'll add one of those. Click add projects, and when you go to metric scope, now we have three projects. So I can monitor all these three projects from this particular project, right? So the two of them are monitored project, and this one is the scoping project. Now let's go to Metrics Explorer. So over here we have three options. One is configuration, which is a GUI based Metrics Explorer. And then we have MQL, which is monetary query language. And then we have Prom MQL. Prom MQL is Prometheus query language. So the first one, let's go to a VM instance metrics, and let's see instance, and let's select CPU utilization. All right. So when I did that, I see CPU utilization as an aggregated view of all the VMs running in past 1 hour. So let's expand this for 6 weeks. And now we see multiple VMs over here, right? So all the CPU utilization, like on this particular day, there were 3 VMs running, and CPU utilization of each of them have been given here. And this is my current VM which is running. So we can add filters to it. Let's say you just want to see only US, only a particular region, right? So add the label as zone, and value, let's give it 1A. So there is only one VM running in region 1A. If we select the other one, which is 1C, we should have the rest of the 3 VMs, right? Now you have added your filter as well. Now, how do you want to view the data? So you could add your group by clause over here. So you can group by using one or more fields. So let's group them by their instance ID. Okay. So now these three instance IDs have these three values, which is basically CPU utilization. Over a period of 1 minute, you could change it to 15 minutes, which makes more sense, right? And then there are some advanced option if you expand this. So you could add a secondary aggregator and secondary aligner as well, right? So this is how you create a matrix from Matrix Explorer to see the utilization of a particular resource over a particular time frame using some filters, group by clause, inclusion and exclusions. Now, if you want to convert everything into a query language, you just click over here and it will be auto converted for you. So the first is table name from which all the metrics would be downloaded. Then we have the metrics name, and then the filter that we applied. Then we have a group by condition every 15 minutes. And there was, I guess, I might have added another group by condition. All the details are over here, and you could make your changes from here as well. And it is pretty handy to use MQL instead of the GUI based Explorer, because you could easily update these queries, reuse it, and while architecting a compute solution with Google Cloud, you need to take care of many important aspects such as your existing infrastructure, your technical requirements, and your business requirements. And based on that, you provide a proposed solution. In this video, we're going to take a look at all those factors that should be kept in mind while selecting the most appropriate compute solution in Google Cloud. So let's take an example. Suppose you have a requirement something like this: your existing infrastructure running a monolithic application, and you need to migrate it to Google Cloud, and there shouldn't be any refactoring of code. Now, which Google Compute solution would you choose? Right? So, in that scenario, if you see your workload is not container based because it is a legacy and monolithic application, so you cannot use the container based solution, and you cannot use fully managed service. Now it is not event driven as well, right? So the option that you have is compute engine. This is what you use. You would do something called as lift and shift, move your existing infrastructure from on-prem to cloud without making any code changes. So this is what you will be using. Now let's take another example. Let's say your requirement is to move your on-prem Kubernetes cluster, right? You have an on-prem K8, and then you have to move it to Google Cloud. And again, you would want to lift and shift without making any code changes, without doing any refactoring, right? So in that case, you would be using something called as GKE. So GKE would be running on Google Cloud. It's a partially managed Kubernetes service. There are two deployment options with GKE. One is standard, and another one is autopilot. Right? With standard, you have the flexibility to manage the underlying nodes. Right? You can make changes in the node, select the number of nodes, and all those things you can do it. But with autopilot, you don't get access to the underlying nodes, but you can still see your workload, you can still your control plane components and all other things. Now, why I say this as a partially managed service? Because your auto upgrades and your node repairs, your patching of servers, those will be still taken care by Google Cloud. So that is why it is partially managed, and partially you have to take care of it. Now, this is the case when you have to migrate your on-prem K8s to Google Cloud, right? So this is what you would use. Now, there would be cases when, let's say, this would be your release 1.0. Now, in next release, you've been tasked to move away from any of the partially managed service and you want to completely go serverless. So in that case, Cloud Run would be a better choice for you. So this is a managed service for Kubernetes where you don't have to manage your servers. So in this, you won't have to do anything other than just run your code and focus on your business logic other than managing server operations and all other tasks, right? So Cloud Run is suitable in that use case. Now let's say your workload is not running on Google Cloud. It is container based and it is running on K8s, but not on Google Cloud. It is running on, let's say, either on AWS or Azure, VMware, bare metal, or even on premises. And there are multiple cluster running in each of those or either of those, and you would have to manage everything from Google Cloud itself. So this is what we use over here is Anthos. Anthos is a very powerful service provided by Google Cloud, and it will give you a single pane of glass for all your Kubernetes cluster, whether running on any of these cloud providers or even on premises. So you can manage all your Kubernetes cluster directly from GCP. Now, let's say your workload is not a monolithic application and it is not container based. You need to check the requirements if it is event driven. Event driven means whether the execution of your application is triggered by any of the events generated in other GCP services, such as a pub subtopic or a cloud storage bucket object notification event. So in that case, if it is event driven, you would use something called as cloud function. So cloud function would be triggered only when an event is received from any other service, and you will be charged based on the execution of code, not
because it won't be running all the time. So whenever you execute your code, whenever you invoke a cloud function, only those number of times you will be charged. If it is not event driven and if it is not container based, but you still want to have a serverless service which is fully managed by GCP, then you would use App Engine. In App Engine, again, there are two offerings. One is App Engine Standard and App Engine Flexible. With Standard, you have some predefined runtimes that you could use, but with Flexible, there is a flexibility to create your own custom runtime, and you can even run containers on top of that. So for App Engine, for GKE, for Compute Engine, I have created separate video with the detailed explanation and the demo as well. But for this video, I just wanted to cover in which scenario we use what type of GCP service and why do we choose it. With App Engine, there is one more benefit of using it. Like if you are using this service, you can have multiple versions of an application running. Let's say you have 1.0 and 1.1 running at the same time, and you can split the traffic between those two services. Let's say you want 50% of the users to access the older version, 50% to access the newer version, like a canary deployment. So in that case, you can use App Engine as well. These are the basic requirements that we should keep in mind while selecting a service, but there could be some low level requirements and you have to do a lot of deep investigation to choose the right service for your use case. Alright, that's it for this video. I hope you enjoyed the video and found it valuable. If you did, give it a thumbs up, comment on the video with your feedback and share with your friends, colleagues, whoever can take advantage to learn from this. And yeah, I will see you soon with the next video. Keep learning, keep upskilling, and yeah, I will see you soon. Thank you so much and have a good day. Bye bye.